There is a moment, if you have ever stood far enough from the city, far enough from the noise and the glow of human things, when the sky above you stops being a backdrop and becomes something else entirely. It becomes a presence. You tilt your head back and the stars are there, not as points on a chart or names in a catalog, but as a sensation, a kind of pressure against the eyes, a weight of light that seems to push down from every direction at once. The Milky Way stretches across the darkness like a river of pale fire, and for a moment, just a moment, you feel something that is very difficult to name. Not smallness, exactly. Something closer to the feeling of standing at the edge of a crowd so vast you cannot see where it ends. The universe in that moment feels full. It feels alive. It feels as though every direction you could possibly look is occupied by something burning, something turning, something reaching outward with its light. That feeling is one of the oldest things human beings have ever felt. It is older than language, older than cities, older than the first scratched marks on cave walls that tried to record what the sky looked like on a particular night. Every civilization that has ever existed under an open sky has looked up and felt, in some version of that same wordless way, that the cosmos is crowded, that it is generous with its light, that the darkness between the stars is just the pause between one bright thing and the next. This is the impression the universe gives, and it is one of the most profound illusions in the history of perception. If you want to follow the questions that reach past the edge of what light can show us, stay with Beyond the Universe, because what we are tracing tonight is not the brightness overhead. It is the nature of everything that surrounds it, everything that dwarfs it, everything that the brightness has been quietly hiding from us all along. The universe is not full. It is not crowded. It is not generous with its light. The feeling you have standing under the stars, that sensation of being surrounded, of being inside something teeming and alive, is a trick of perception so deep and so complete that it took centuries of careful, painstaking science to begin to see through it. And even now, even with everything we know, the illusion reasserts itself every time you look up, because the human eye is drawn to light, the human mind is drawn to pattern, and the universe, it turns out, has arranged its light in exactly the way most likely to fool a creature like us into thinking there is more of it than there is. Consider what you are actually seeing when you look at the night sky. You are seeing the rare exceptions. You are seeing the tiny fraction of matter in the universe that happens to be undergoing nuclear fusion, that happens to be hot enough and dense enough to radiate energy across the void in wavelengths your eyes can detect. Every star you see is an anomaly. Every glowing nebula is a local accident of density and heat. Every galaxy you can find with a telescope is a knot of matter that managed, against the overwhelming tendency of the cosmos, to gather itself together and ignite. What you are not seeing, what you cannot see, what fills the overwhelming majority of the space between every bright thing you have ever observed, is nothing, or something so close to nothing that the difference barely matters. This is not a poetic statement. It is not a philosophical provocation. It is a description of the actual geometry of the universe, measured and mapped and confirmed by decades of observation. The universe is, by almost any meaningful measure, almost entirely empty. And the emptiness is not a border condition, not a thin margin around the interesting parts. The emptiness is the main event. The light is the footnote. While the window is still open, subscribe to Beyond the Universe. These questions won't wait forever, neither will the light. To begin to feel the true scale of this, you have to start somewhere familiar, and then let the scale pull you outward until familiar things stop making sense. Start with the atom. The atom is the building block of everything you have ever touched, everything you have ever seen, everything that has ever been called matter. And the atom is almost entirely empty space. The nucleus at its center, where almost all of its mass is concentrated, is so small relative to the atom's total volume that if you were to expand a single hydrogen atom to the size of a cathedral, the nucleus would be roughly the size of a grain of sand on the floor. The electrons that orbit it would be somewhere near the walls, and between them and that grain of sand there would be nothing. No substance, no medium, just the abstract geometry of quantum fields and the strange rules that govern them. The matter you are made of is not solid in any meaningful sense. It is a pattern of forces arranged in mostly empty space, but that is only the beginning. Step back from the atom and look at the solar system. The sun sits at the center, enormous by any human standard, a sphere of plasma so large that more than 1 million Earths could fit inside it. And yet the solar system is almost entirely empty. The distance from the Sun to the Earth is roughly 150 million kilometers. The distance from the Sun to Neptune, the outermost major planet, is about 30 times that. And in all of that volume, in all of that vast spherical region of space, The total mass of everything that is not the sun, all the planets, all the moons, all the asteroids, all the comets, all the dust, amounts to less than a fraction of a percent of the sun's own mass. The solar system is not a crowded place. It is an enormous emptiness with a few small objects scattered through it at distances so large that if you shrank the sun to the size of a grapefruit, the nearest planet would be roughly 10 meters away, and the nearest star would be somewhere on the other side of the continent. And this leads to something more disturbing. Because the solar system is not unusual, it is not an exceptionally empty corner of the galaxy. It is typical. The distances between stars in the Milky Way are so vast that the concept of crowding becomes almost meaningless. The nearest star to our sun, Proxima Centauri, is about 4 light-years away. 4 years of travel at the speed of light, the fastest speed that physics permits anything to move. If you were to shrink the entire Milky Way galaxy down to the size of a continent, the distance between individual stars would still be measured in kilometers. The galaxy looks dense from the outside, a glowing disk of light, but from the inside it is an ocean of darkness with islands of fire separated by distances that no human technology has ever come close to crossing. The Milky Way contains somewhere between 200 billion and 400 billion stars. That number is so large it resists comprehension. If you counted 1 star per second without stopping, it would take you more than 6,000 years to count them all. And yet, if you were to take all of those stars and all of the space they occupy and calculate the average density of matter in the galaxy, you would find that the Milky Way is, by the standards of the laboratory, an extraordinarily good vacuum. The matter is there, but it is spread so thin across such enormous distances that the galaxy is, in the most literal physical sense, almost nothing. But it gets worse, because the Milky Way is not alone, and the space between galaxies makes the space between stars look intimate by comparison. The Milky Way and its nearest large neighbor, the Andromeda Galaxy, are separated by roughly 2.5 million light-years. 2.5 million years of travel at the speed of light. In that gap, there is almost nothing. A few dwarf galaxies, some scattered stars that were flung out of their home galaxies by gravitational interactions, thin wisps of gas so diffuse they barely register. The intergalactic medium, the material that fills the space between galaxies, is the closest thing to a perfect vacuum that nature produces. It is so thin that a cubic meter of it contains, on average, fewer than a handful of atoms. Compare that to the air you are breathing right now, which contains roughly 10 to the power of 25 molecules per cubic meter, and you begin to feel the scale of the difference. And yet even this, even the staggering emptiness between individual galaxies, is not the deepest level of the void. Because galaxies are not distributed randomly through space. They are not scattered evenly like dust in a room. They are gathered, clustered, arranged into structures that, when you pull back far enough to see them whole, reveal something that no one expected, and that once seen, is very difficult to stop thinking about. When astronomers began mapping the large-scale distribution of galaxies in the latter half of the 20th century, they expected to find something roughly uniform, perhaps some clustering here and there, some regions slightly denser than others, but broadly speaking a cosmos that looked more or less the same in every direction at large enough scales. What they found instead was something that looked like nothing so much as a vast three-dimensional web. Galaxies were not spread evenly. They were concentrated along thin filaments, long threads of matter stretching across hundreds of millions of light-years, connecting at nodes where enormous clusters of galaxies gathered like bright knots in a net. And between the filaments, between the threads and the knots, there were regions of space that contained almost nothing at all. Not sparse regions, not underdense regions, regions that were, by any reasonable definition, empty. Vast, spherical, almost perfectly hollow volumes of space, each one hundreds of millions of light-years across, where the density of matter was so low that galaxies barely existed. These regions have a name. They are called cosmic voids, and they are, in terms of sheer volume, the dominant feature of the universe. When you add up all the space occupied by the filaments and the clusters and the walls of galaxies, and then compare it to the space occupied by the voids win by an enormous margin. The universe, at its largest scales, is not a collection of galaxies with some empty space between them. It is a collection of enormous empty spaces with some galaxies arranged along their edges. The structure is inverted from what intuition suggests. The galaxies are not the body of the universe. They are the skin of the bubbles. The emptiness is the body. This is the moment when the night sky begins to look different. Not immediately, not all at once, but in the way that a familiar room looks different after you have learned something unsettling about it. The stars are still there, the Milky Way still arches overhead, But now you know that what you are looking at is a thin, luminous trace, a narrow thread of matter clinging to the surface of a void so large that the entire observable universe contains hundreds of them. You are not standing inside a full universe. You are standing on the wall of an enormous empty room, looking at the decorations on the wallpaper and mistaking the decorations for the room itself. The cosmic web, as it has come to be called, is one of the most extraordinary structures that science has ever revealed. It extends across the entire observable universe, which itself spans roughly 93 billion light-years in diameter. The filaments that make up the web are not thin in any human sense. They are hundreds of millions of light-years long, containing thousands of galaxies, threaded through with dark matter and hot gas. The clusters at their intersections are among the most massive gravitationally bound objects in the universe, containing hundreds or thousands of individual galaxies, each one a collection of hundreds of billions of stars. And yet all of this staggering accumulation of matter and light and gravity, occupies only a small fraction of the total volume of the observable universe. The rest is void. There is a particular void that astronomers have studied more carefully than most, a region of space that has been mapped and measured and found to be genuinely, almost incomprehensibly empty. It sits in the direction of the constellation Boötes, and it spans roughly 300 million light-years across. Inside it, there are almost no galaxies. Not few galaxies, almost none. A region of space 300 million light-years wide, and it is essentially hollow. When this void was first discovered in the 1980s, astronomers were so surprised by its size and emptiness that some of them initially doubted the data. It seemed too large, too empty, too much like a hole in the universe to be real. But it was real, and it was not alone. The universe is full of such voids, each one a vast dark room that the light of galaxies barely touches. Standing under the night sky, you see perhaps a few thousand stars with the naked eye on a clear night. With a good telescope, you can see millions. With the most powerful instruments ever built, we have detected hundreds of billions of galaxies in the observable universe. And yet all of those galaxies, all of that light, all of that matter, is arranged along the surfaces of structures whose interiors are defined by absence. The universe has organized itself around emptiness. It has built its architecture out of nothing and hung its lights along the edges of the dark. But it goes deeper, because the question of why the universe is structured this way, why matter gathered into filaments and left the voids empty, why the cosmic web has the shape it has, leads to something that is in some ways more unsettling than the emptiness itself. It leads to the realization that the universe we can see, the matter that shines and glows and reflects light, the matter that makes up every star and planet and galaxy and nebula, is not the primary ingredient of the cosmos. It is not even close to the primary ingredient. The visible universe, everything that has ever been detected by any telescope or instrument ever built, accounts for only a small fraction of the total matter and energy content of the cosmos. The rest is something else, something that does not shine, something that does not interact with light in any way we can directly observe, something that is, in the most literal sense, invisible. The first hints of this came not from cosmology, but from the motion of galaxies. In the 1930s, an astronomer named Fritz Zwicky was studying a cluster of galaxies called the Coma Cluster, measuring the velocities of individual galaxies within it. What he found was deeply puzzling. The galaxies were moving far too fast. If the only gravity holding the cluster together was the gravity produced by the visible matter, the galaxies, the stars, the gas, then the cluster should have flown apart long ago. The velocities were too high, the visible mass too low. Something else had to be providing the gravitational glue, something that was not visible. Zwicky called it dunkel materie, dark matter. For decades, this idea was treated with skepticism. It seemed too convenient, too much like inventing an invisible substance to explain away an inconvenient measurement, but the evidence kept accumulating. In the 1970s, astronomer Vera Rubin and her colleagues were measuring the rotation curves of spiral galaxies, tracking how fast stars at different distances from the galactic center were orbiting. According to the laws of gravity, stars far from the center, where most of the visible mass is concentrated, should orbit more slowly, just as the outer planets of the solar system orbit more slowly than the inner ones. But they did not. Stars at the outer edges of galaxies were orbiting just as fast as stars near the center, sometimes faster. The rotation curves were flat when they should have been declining. The only explanation that fit the data was that there was a vast halo of invisible matter surrounding each galaxy, extending far beyond the visible disk, providing the gravitational pull needed to keep the outer stars in their orbits. This was not a small correction. The amount of dark matter required to explain the observations was not a modest addition to the visible mass. It was several times the visible mass. For every kilogram of ordinary matter in a galaxy, there were several kilograms of dark matter surrounding it, invisible, undetectable by any means other than its gravitational influence. The visible galaxy, the glowing disk of stars and gas that you see in telescope images, was revealed to be only the bright core of a much larger, much more massive, completely invisible structure. The galaxy you see is not the galaxy. It is the lit portion of something far larger and far darker. And this leads to something more disturbing. Because dark matter is not just a property of individual galaxies, it is the scaffolding of the entire cosmic web. The filaments, the clusters, the walls of galaxies that define the large-scale structure of the universe. They did not form because ordinary matter gathered together under its own gravity. They formed because dark matter gathered first. In the early universe, dark matter began to clump under its own gravitational attraction, forming the invisible skeleton of what would eventually become the cosmic web. Ordinary matter, the atoms and molecules that make up stars and planets, and everything you have ever touched, fell into the gravitational wells that dark matter had already carved out. The galaxies formed where the dark matter told them to form. The filaments traced the dark matter filaments beneath them. The voids are empty because the dark matter left them empty. The universe you see is a map drawn on top of a map you cannot see. The visible structure is a consequence of the invisible structure. The light follows the dark, and the dark matter, this invisible gravitational architecture that shapes everything, that determines where galaxies form and how they move and what the large-scale structure of the cosmos looks like, we do not know what it is. After nearly a century of searching, after decades of experiments designed specifically to detect it, after the construction of detectors buried deep underground to shield them from interference, after the analysis of data from particle accelerators and space telescopes and gravitational lensing surveys, we still do not know what dark matter is made of. We know it is there. We know it is real. We know it outweighs ordinary matter by a factor of roughly 5 to 1. And we cannot see it, touch it, or identify it. 5 to 1. For every atom of ordinary matter in the universe, every proton and neutron and electron that makes up every star and planet and human being and grain of dust, there are roughly 5 times as much dark matter. The universe is not mostly made of the things we can see. It is mostly made of something we cannot see. Something that passes through ordinary matter as though ordinary matter were not there. Something that has been shaping the cosmos since the earliest moments after the Big Bang, without ever once announcing its presence through light or heat or any signal we know how to read directly. And yet, as strange as dark matter is, as unsettling as it is to realize that the primary ingredient of the universe is invisible to us, dark matter is at least a form of matter. It has mass. It gravitates. It participates in the universe in a way that, while invisible, is at least comprehensible in terms of the physics we understand. What comes next is harder. What comes next is something that does not behave like matter at all, something that does not gather and clump and build structure, but instead does the opposite, something that pushes, something that is not content to let the universe simply exist as it is, but is actively, relentlessly driving it apart. To understand what this means, you have to go back to the night sky one more time. Look at the stars. Look at the Milky Way. Look at the sense of stillness, of permanence, of a universe that has always been this way and will always be this way. That sense is wrong in a way that goes beyond the emptiness, beyond the dark matter, beyond everything we have discussed so far. The universe is not still. It is not permanent. It is not even stable in the way that a rock or a mountain is stable. The universe is moving. Every galaxy beyond our local group is moving away from us, not because it was thrown outward by some explosion, not because it is traveling through space in the way a ball travels through air, but because the space between us and it is growing. The fabric of the cosmos itself is expanding, stretching, carrying the galaxies apart like raisins in a rising loaf of bread, except that the bread has no edges and no center and no baker, and it has been rising since the beginning of time. This was discovered in the 1920s when Edwin Hubble and his colleagues measured the distances to nearby galaxies and found that the farther a galaxy was, the faster it appeared to be receding. The universe was expanding. This was one of the most profound discoveries in the history of science, and it immediately raised a question that seemed to have an obvious answer. If the universe is expanding now, it must have been smaller in the past. And if you run the expansion backward far enough, you arrive at a moment when everything was compressed into an unimaginably small, unimaginably hot, unimaginably dense state. The beginning, the Big Bang. But the expansion raised another question, one that seemed equally obvious and whose answer turned out to be far less comfortable. If the universe is expanding, and if gravity is pulling all of its matter together, then the expansion should be slowing down. The galaxies should be moving apart more slowly now than they were in the past, gradually decelerating under the mutual gravitational attraction of all the matter in the cosmos. Eventually, perhaps the expansion would stop. Perhaps it would reverse. Perhaps the universe would one day begin to contract, collapsing back toward a final singularity, a mirror image of the Big Bang. Or perhaps the expansion would continue forever, but ever more slowly, the galaxies drifting apart at a pace that diminished with each passing billion years. Either way, the expectation was clear: the expansion should be slowing. In 1998, two independent teams of astronomers set out to measure exactly how much the expansion was slowing. They used a particular type of exploding star, a type Ia supernova, as a standard candle, a light source of known brightness that could be used to measure distances across billions of light years. They expected to find deceleration. They found the opposite. The expansion of the universe is not slowing down, it is speeding up. The galaxies are not drifting apart more slowly as time passes. They are drifting apart faster. Something is pushing the universe apart, accelerating the expansion, working against gravity on the largest scales. Something that fills all of space, that has no source and no center, that does not dilute as the universe expands, but maintains its influence across every cubic meter of the cosmos. Something that, for lack of a better name, we call dark energy. The discovery of dark energy was so unexpected, so difficult to reconcile with existing physics, that the astronomers who made it spent years checking and rechecking their data before they were willing to publish. When they did publish, the result was met with a mixture of astonishment and deep unease. Not because it was implausible, but because it was true, and because its implications were difficult to absorb. Dark energy is not a small effect. It is not a minor correction to the standard picture of cosmic evolution. It is the dominant component of the universe. Of all the matter and energy in the cosmos, roughly 68% is dark energy. Dark matter accounts for roughly 27%. Ordinary matter, everything you can see, everything that has ever been detected by any instrument, every star, every planet, every galaxy, every atom of gas in the intergalactic medium, accounts for roughly 5% of the total content of the universe. 5%. The universe that we can observe, the universe that we have spent centuries studying and mapping and trying to understand, is 5% of what is actually there. The other 95% is invisible, unknown, and in the case of dark energy, actively working to pull the cosmos apart. We are not standing in the universe. We are standing in the visible residue of the universe, the thin, luminous skin on the surface of something vast and dark and largely beyond our comprehension. And this is where the night sky begins to feel not just vast, not just empty, but strange in a way that is difficult to articulate, because the stars overhead are not just distant. They are not just separated from you by enormous gulfs of empty space. They are receding. The universe is not a static backdrop against which events unfold. It is a dynamic, expanding, accelerating structure that is, at this very moment, carrying the distant galaxies away from us at speeds that increase with distance. Galaxies far enough away are already receding faster than the speed of light, not because they are moving through space faster than light, but because the space between us and them is growing so rapidly that the distance increases faster than light can cross it. Their light will never reach us. They are already, in a meaningful sense, beyond our reach. But it gets worse, because the acceleration means that more and more galaxies will cross this horizon over time. Galaxies that are currently visible, galaxies whose light is reaching us right now, will eventually recede beyond the point where their light can reach us. The observable universe is not a fixed thing. It is shrinking, in the sense that the number of galaxies we can in principle observe is decreasing. The cosmos is not opening up as it expands. It is closing off. The horizon is drawing inward, not in terms of physical distance, but in terms of what is causally connected to us, what can in principle send us a signal, what we can in principle know about. There is something in this that goes beyond the merely scientific, something that touches a deeper register of unease. The universe is not just large. It is not just mostly empty. It is actively becoming less knowable. The information that would allow a future observer to understand the full scope of the cosmos is being carried away, beyond reach, into a darkness that is not the darkness of night, but the darkness of permanent inaccessibility. The universe is not hiding its secrets. It is erasing them, and it has been doing so since the moment the acceleration began. quietly, relentlessly, without any regard for the creatures who might one day wish to understand it. Look up at the night sky one more time. The stars are still there. The Milky Way still glows. The universe still looks full and alive and generous with its light. But you know now that this is the view from inside the illusion. You know that the light you see is the exception, not the rule. You know that the space between the stars is almost perfectly empty, and the space between the galaxies is emptier still, and the space inside the cosmic voids is emptier than anything that can be produced in a laboratory on Earth. You know that the structure of the cosmos, the filaments and clusters and walls of galaxies, is arranged around enormous hollow regions that define the true geometry of the universe. You know that the visible matter is only 5% of what is there, that the rest is dark and invisible and largely unknown. And you know that the universe is expanding, accelerating, carrying the distant galaxies beyond the reach of any future observer, erasing the evidence of its own history. This is not the end of the story. It is barely the beginning, because the emptiness of space, the invisibility of most of the universe's content, the acceleration of cosmic expansion, these are the conditions of the universe as it exists right now, in this particular moment of cosmic time. What happens next? What the universe becomes as time continues to pass, as the expansion continues to accelerate, as the stars burn through their fuel and the galaxies age, and the great structures of the cosmic web slowly dissolve, is a story that makes the present emptiness look almost crowded by comparison. The universe is not finished becoming empty. It has barely started. The night sky you see tonight is a snapshot of a particular moment in cosmic history, a moment that will not last. The stars overhead are not permanent fixtures. They are fires, and fires go out. The galaxies are not eternal structures. They are temporary gatherings of matter that will, over timescales almost impossible to hold in the mind, disperse and fade and go dark. The cosmic web, that vast architecture of filaments and voids that defines the large-scale structure of the universe, is not a permanent feature of reality. It is a phase, a particular arrangement of matter that exists for a finite time before the expansion tears it apart and the darkness reclaims what the light briefly held. The universe is not moving toward fullness. It is not building toward some final state of complexity and brightness and meaning. It is moving in the other direction. It is moving toward separation, toward thinning, toward a condition in which the distances between things become so large that the things themselves cease to matter, cease to interact, cease to be part of any shared story. The universe is moving toward a silence so complete that the word silence does not quite capture it, because silence implies the absence of sound in a place where sound could exist. What the universe is moving toward is something more fundamental than silence. It is moving toward a condition in which the very possibility of communication, of connection, of one thing affecting another, has been stretched so thin by the expansion of space that it effectively vanishes. But to understand how that happens, to follow the story from where we are now to where the universe is going, you have to understand what the universe is made of in a different sense, not in terms of dark matter and dark energy and ordinary matter, but in terms of what ordinary matter does over time, what it builds, and how long those buildings last, and what happens when the fuel runs out and the lights begin to go dark one by one. You have to understand the life cycle of stars, and the death of galaxies, and the long, cold, patient process by which the universe dismantles everything it has ever made. And that story begins with a single, simple, deeply unsettling fact. The universe is spending something it cannot replenish, and it has been spending it since the very beginning. Every star in the night sky is a furnace, not a metaphor for a furnace, not something that resembles a furnace in a poetic sense, but an actual thermonuclear reactor, a place where matter is being converted into energy at a rate so enormous that the human mind has no natural scale for it. The sun, which is an ordinary star, unremarkable by the standards of the galaxy, converts roughly 4 million metric tons of mass into energy every single second. Every second. It has been doing this for approximately 4.5 billion years, and it will continue doing it for roughly another 5 billion years before its fuel begins to run critically low and its behavior begins to change in ways that will be catastrophic for anything living in its vicinity. The sun is not eternal. It is a fire with a finite amount of fuel, burning in a universe that does not replenish what is consumed. This is the fact that underlies everything that follows. The universe was born with a certain inventory of hydrogen, the simplest element, the raw fuel of stars. That hydrogen has been, since the first stars ignited a few 100 million years after the Big Bang, being steadily converted into heavier elements through the process of nuclear fusion. Every star that has ever burned has taken some of that primordial hydrogen and turned it into helium, and then, in the more massive stars, into carbon and oxygen and silicon and iron, and then scattered those heavier elements back into space when the star died. The universe has been running this process for nearly 14 billion years. It has been spending its hydrogen, and hydrogen, once fused into heavier elements, does not spontaneously return to its original form. The universe's fuel supply is not being replenished. It is being drawn down slowly but irreversibly with every star that shines. Right now, in this current era of cosmic history, the universe is still forming new stars. Gas clouds and galaxies collapse under gravity, heat up, ignite, and new stars are born. This has been happening continuously since the early universe, and it is still happening today. But it is not happening at the same rate it once did. The peak of star formation in the universe occurred roughly 10 billion years ago, when the cosmos was young, and gas was abundant, and galaxies were colliding and merging and stirring up their interstellar material into frenzies of new stellar birth. Since that peak, the rate of star formation across the universe has been declining. Not dramatically, not all at once, but steadily, measurably, in a long, slow curve that points in only one direction. The universe is making fewer new stars than it used to, and as time passes it will make fewer still. This decline is not a temporary fluctuation. It is not a phase that will reverse when conditions change. It is a structural feature of cosmic evolution, driven by the simple fact that the raw material for star formation, cold dense gas, is being used up. When a star forms, it takes gas out of circulation. When it dies, it returns some of that gas to the interstellar medium, but not all of it. Some of the mass is locked up in the stellar remnant, the white dwarf or neutron star or black hole that the star leaves behind. Some of it is blown out of the galaxy entirely by the violence of stellar winds and supernova explosions. Over billions of years, the gas available for new star formation in a galaxy gradually diminishes. The galaxy ages. Its star-forming regions quiet down. The brilliant blue light of young massive stars fades as those stars burn through their fuel and die, and is not fully replaced by new ones. The galaxy grows redder, older, quieter, but it goes deeper, because the decline of star formation is not just a local phenomenon, not just something happening in individual galaxies as they age. It is a universal trend, written into the large-scale evolution of the cosmos, and it is being accelerated by the very force we have already encountered, dark energy. As the expansion of the universe accelerates, the density of matter in any given region of space decreases. The filaments of the cosmic web become more stretched, more tenuous. The flow of gas between galaxies, the streams of material that feed star formation, become thinner and eventually stop. Galaxies become increasingly isolated, cut off from the fresh supplies of gas that would allow them to continue making new stars. They are left to work with what they have, and what they have is finite. There is a way of thinking about this that makes it feel very immediate, very personal, even though the timescales involved are almost incomprehensibly long. Imagine a city that is slowly running out of building materials. At first, the construction continues almost normally. New buildings go up, old ones are demolished and their materials recycled. The city grows and changes and hums with activity. But gradually, the supply of raw materials dwindles. New construction slows. The recycling becomes less efficient. Old buildings are not replaced when they fall. The city does not collapse all at once. It simply becomes, over a very long time, quieter, less new, more dominated by old structures that are slowly deteriorating. And eventually, if you wait long enough, the construction stops entirely, and what remains is only what was already built, aging in place, with nothing new being added. The universe is that city, and the building materials are hydrogen, and the construction is star formation, and the timeline is not decades or centuries but billions and trillions of years. But the direction is the same. The universe is not building toward something. It is winding down from something. The peak of cosmic construction is behind us. We live in the long afternoon of the universe's creative era, and the evening is coming, slowly, but without any possibility of reversal. And this leads to something more disturbing. Because when you think about what the universe will look like in the far future, when the current generation of stars has burned out and the rate of new star formation has dropped to nearly zero, you are not imagining a universe that looks like ours but darker. You are imagining a universe that is fundamentally different in character. A universe in which the night sky, if anyone were there to see it, would not look like the night sky you know. It would look like something else entirely. Something emptier, something older, something that carries in its appearance the unmistakable signature of a process that has been running for a very long time and is approaching its end. To follow this story properly, you have to understand something about the different kinds of stars, because not all stars burn at the same rate or die at the same time. The most massive stars, the giants that blaze with a blue-white intensity that makes them visible across enormous distances, burn through their fuel with extraordinary speed. A star 10 times the mass of the Sun may live for only a few tens of millions of years before exhausting its core hydrogen and undergoing the catastrophic collapse that produces a supernova. These stars are spectacular, but they are brief. They are the mayflies of the stellar world, brilliant and short-lived, and their deaths scatter heavy elements across the galaxy in explosions that briefly outshine entire galaxies. Stars like the Sun, middleweight stars of modest mass and moderate temperature, live much longer. The Sun's total lifespan will be roughly 10 billion years, of which about half has already passed. When it finally exhausts the hydrogen in its core, it will expand into a red giant, swelling to a size that will engulf the inner planets, and then shed its outer layers in a beautiful but lethal cloud of gas called a planetary nebula, leaving behind a dense, hot, slowly cooling remnant called a white dwarf. The white dwarf is not a star in the active sense. It is not fusing hydrogen. It is simply the compressed, cooling core of what was once a star, radiating away the heat it accumulated over its lifetime, growing dimmer and cooler over billions of years until it fades to a cold, dark object called a black dwarf. No black dwarfs exist yet in the universe. The universe is not old enough. The cooling process takes longer than the current age of the cosmos, but they are coming. And then there are the red dwarfs. These are the smallest, coolest, dimmest stars, so faint that not a single one is visible to the naked eye despite the fact that they are the most common type of star in the galaxy. Red dwarfs are miserly with their fuel. They burn so slowly, so carefully, so efficiently, that they can sustain nuclear fusion for timescales that dwarf the current age of the universe by enormous factors. The least massive red dwarfs may burn for 10 trillion years. 10 trillion. The current age of the universe is roughly 14 billion years. A 10 trillion year stellar lifetime is more than 700 times longer than the universe has currently existed. These stars will still be burning long after every sun-like star in the galaxy has died and cooled to darkness. They are the last lights, the embers that will outlast everything else in the stellar inventory. But even the red dwarfs will eventually go out. Even the most miserly star has a finite supply of fuel. And when the last red dwarf exhausts its hydrogen and fades to a cold, dark remnant, the era of stars will be over. Not diminished, not reduced. Over. The universe will enter a phase in which no new stars are forming and no existing stars are burning. A phase in which the only sources of light are the slowly cooling remnants of dead stars and the occasional violent event produced by the gravitational interactions of those remnants. A phase that astronomers with a kind of bleak poetry call the degenerate era. The degenerate era will be populated by white dwarfs cooling toward black dwarfs, by neutron stars spinning down and going cold, by rogue planets, and brown dwarfs drifting through the darkness between dead galaxies, by the occasional collision or merger of stellar remnants, producing a brief flare of light in an otherwise dark sky. It will be a universe that still contains matter, still contains structure in a loose sense, but no longer contains the kind of organized, sustained energy release that we associate with life and light, and the possibility of complexity. It will be a universe in which the concept of a night sky has lost most of its meaning, because the sky will be almost entirely dark, and the rare dim objects visible in it will be the cold graves of stars that burned out billions or trillions of years before. But it gets worse, because even the degenerate era is not the final state of the universe. Even the cold remnants of dead stars are not permanent. Even the matter that survives the death of the stellar era is subject to processes that will, over time scales so large they require a different relationship with the concept of time, dismantle it further. And the agent of this further dismantling is something that has been present throughout the entire story, something that has been quietly accumulating mass and influence since the earliest moments of the universe, something that we have mentioned but not yet fully confronted: the black holes. Black holes are among the most extreme objects in the universe, places where matter has been compressed to such density that the gravitational field becomes so strong that nothing, not matter, not light, not any signal of any kind, can escape from within a certain radius. They form when massive stars die in supernova explosions and their cores collapse beyond the point where any known force can halt the compression. They also form through a different process at the centers of galaxies, where they grow to masses millions or billions of times that of the Sun by consuming gas and stars and merging with other black holes over billions of years. These supermassive black holes sit at the hearts of most large galaxies, including our own Milky Way, where a black hole called Sagittarius A contains roughly 4 million solar masses in a region smaller than our solar system. For most of cosmic history, black holes have been consumers. They have taken in matter and energy and added to their mass. They have shaped the evolution of galaxies by releasing enormous amounts of energy when they actively feed, driving jets of plasma across hundreds of thousands of light years, heating the gas in galaxy clusters, regulating the rate of star formation. They have been, in a sense, the most powerful engines in the universe, converting matter into energy with an efficiency that nuclear fusion cannot approach. But they have also been, in another sense, the universe's most patient collectors, accumulating mass over billions of years, growing slowly larger, waiting. What they are waiting for, though they do not wait in any intentional sense, is the era when everything else has gone dark. Because in the far future, when the stars have burned out and the galaxies have faded and the degenerate era has run its course, the black holes will still be there. They will be the dominant large-scale structures in the universe. The dead galaxies will have dispersed, their stellar remnants scattered by gravitational interactions over trillions of years, but the supermassive black holes at their centers will remain, drifting through the darkness, occasionally merging with each other when their paths cross, growing slowly larger. For a time, an enormously long time, the universe will be a place of black holes and cold, dark remnants and thin radiation, and almost nothing else. And then, even this will change, because black holes are not eternal. This was one of the most surprising and philosophically disturbing discoveries in the history of theoretical physics, and it came not from observation but from calculation. In the 1970s, the physicist Stephen Hawking combined the principles of quantum mechanics with the geometry of black holes and arrived at a result that seemed almost impossible. Black holes, he found, are not perfectly black. They radiate, not because anything escapes from inside the event horizon, but because of quantum effects at the boundary. The horizon itself produces a faint, cold radiation, now called Hawking radiation, and in doing so, the black hole slowly loses mass. Slowly is an understatement of almost criminal proportions. A black hole the mass of the Sun would take roughly 2 times 10 to the power of 67 years to evaporate completely through Hawking radiation. A supermassive black hole of 1 billion solar masses would take incomparably longer. These are numbers that do not correspond to any human experience of time, numbers that make the current age of the universe look like the first fraction of a second of a process that has barely begun. But they will evaporate. Given enough time, and the universe will have enough time, every black hole will eventually radiate away all of its mass and disappear in a final burst of high-energy radiation. And when the last black hole evaporates, the universe will enter its final era, an era with no stars, no planets, no galaxies, no black holes. An era populated only by the thin, cold radiation left over from all the processes that came before, by the occasional lone particle drifting through an almost perfectly empty space, by a darkness so complete and a silence so absolute that the word emptiness does not begin to describe it. This is the heat death of the universe. Not a dramatic end, not an explosion or a collapse, but a slow, patient, inevitable approach to a state of maximum entropy, a state in which all useful differences have been erased, all gradients have been smoothed out, all the organized structures that allowed complexity and life and thought to exist have dissolved into a uniform, featureless, cold expanse. The universe will not end with a bang. It will end with a whisper so faint that there will be nothing left to hear it. Entropy is the concept that underlies all of this, and it is worth pausing on it, not to define it in the way a textbook would, but to feel what it means in the context of a universe that is 14 billion years old and has trillions of years still ahead of it. Entropy is, in the most intuitive sense, the tendency of organized things to become disorganized, the tendency of hot things to cool, the tendency of concentrated energy to spread out, the tendency of complex structures to simplify. It is not a force in the way gravity is a force, it is more like a direction, a statistical inevitability built into the nature of large systems. There are vastly more ways for a system to be disordered than to be ordered, and so, given enough time and enough random interactions, systems tend toward disorder, not because disorder is in any sense preferred, but because it is overwhelmingly more probable. The universe began in a state of extraordinarily low entropy. The Big Bang produced a cosmos that was, Despite its enormous temperature and energy, highly ordered in a specific thermodynamic sense, the matter was distributed almost perfectly uniformly, with only tiny quantum fluctuations that would later grow into the cosmic web. The energy was concentrated in a way that allowed it to do work, to drive processes, to build structure. And since that beginning, the universe has been moving inexorably toward higher entropy. Every star that burns is converting low-entropy fuel into high-entropy radiation. Every supernova that scatters heavy elements is spreading organized matter into disordered gas. Every galaxy that ages and fades is moving from a state of active organized energy release to a state of cold, dispersed remnants. The universe is not building toward something, it is running down from something. And the direction of that running down is fixed by the laws of thermodynamics, which are, as far as we know, absolute. There is a particular image that captures something of what this means, though no image can fully contain it. Imagine a fire burning in a fireplace. The wood is organized, structured, chemically complex. The fire converts it into heat and light and ash and carbon dioxide. The heat spreads through the room and eventually through the walls and into the outside air. The light travels outward and is absorbed by surfaces and converted to heat. The ash sits cold in the grate. The carbon dioxide drifts into the atmosphere. Nothing has been destroyed in the sense of ceasing to exist. All the atoms are still there. All the energy is still there, but it has been spread out, diluted, made unavailable for further work. The fire cannot be unburned. The heat cannot be gathered back into the wood. The process is irreversible, and the universe is that fire, burning on a scale and over a duration that makes the comparison almost absurd, but burning in the same direction, toward the same cold, dispersed, unavailable end. But it goes deeper, because entropy is not just about energy, it is about information. It is about the difference between a state that contains a record of the past and a state that does not. When a fire burns, the information encoded in the structure of the wood, the arrangement of its molecules, the pattern of its grain, is not just converted to a different form, it is, in a practical sense, lost. The ash and the dispersed heat do not contain a readable record of the wood that produced them. The information has been scrambled beyond recovery, and this is what the universe is doing on a cosmic scale. It is scrambling its own history. It is converting the organized, information-rich structures of stars and galaxies and planets into dispersed, featureless radiation that carries no readable record of what produced it. And this connects back to something we touched on earlier, the disappearance of distant galaxies beyond the cosmic horizon. Because the universe is erasing its history in two ways simultaneously. It is erasing it physically, through entropy, by converting organized structures into disordered radiation. And it is erasing it informationally, through expansion, by carrying the evidence of distant events beyond the reach of any observer. A future civilization, arising in the far future in some corner of the universe that still supports complexity, would face a cosmos that has been doubly erased. The physical structures that existed in the past would be gone, dissolved by entropy, and the light that carried information about those structures would be gone, carried beyond the horizon by expansion. The past would be not merely over but inaccessible, not merely inaccessible but undetectable, not merely undetectable but, in the most complete sense, gone. This is one of the most quietly disturbing ideas in all of cosmology. We live in a privileged moment, not privileged in the sense of being special or chosen, but privileged in the sense of having access to information that will not always be available. We can look out at the night sky and see hundreds of billions of galaxies. We can measure the cosmic microwave background radiation, the faint afterglow of the Big Bang, and read in it the initial conditions of the universe. We can trace the large-scale structure of the cosmic web and infer the properties of dark matter and dark energy. We can, in principle, reconstruct a significant portion of the history of the cosmos from the evidence that is currently available to us. But this window is closing. The expansion is carrying the evidence away. The entropy is scrambling what remains, and there will come a time, not soon by any human standard, but inevitable by any cosmic standard, when the window has closed entirely, and whatever observers exist will look out at a universe that appears to have no history, no origin, no context. A universe that simply is, cold and dark and thin, with no story attached to it. Future observers. It is worth pausing on that phrase because it raises a question this entire journey has been quietly moving toward. Will there be observers in the far future? Will there be anything capable of looking out at the universe and wondering about it? This is not a question with a confident answer. Life as we know it depends on a very specific set of conditions: liquid water, chemical complexity, a stable energy source, a temperature range narrow enough to allow the chemistry of biology to function. All of these conditions depend ultimately on stars. Stars provide the energy that drives chemistry on planetary surfaces. Stars produce the heavy elements that make complex chemistry possible. Stars warm the planets that orbit them to temperatures where liquid water can exist. Without stars, the conditions for life as we know it cannot be maintained. As the stars go out one by one, over the trillions of years of the degenerate era, the habitable zones of the universe will shrink and eventually vanish. The last red dwarfs will provide warmth and light for the planets that orbit them for an almost incomprehensibly long time, but eventually they too will fade. And when they do, the universe will become, as far as we can tell, uninhabitable by any form of life that resembles what we know. Whether some radically different form of complexity could persist in the cold, dark, low-energy environment of the far future is a question that cannot be answered with confidence. It is possible to imagine, in a speculative way, processes of extraordinary slowness that might constitute something like thought or experience in a universe where the available energy is vanishingly small. But these are speculations, and they do not change the fundamental trajectory. The universe is moving away from the conditions that support complexity, not toward them. And this leads to something more disturbing, because if the universe is moving away from the conditions that support complexity, and if complexity is what produces observers, and if observers are what give the universe something like meaning, in the only sense we know how to assign meaning, then the universe is moving away from meaning, not in a dramatic, intentional way. Not because it has decided to abandon the project of complexity, but simply because the laws of physics, applied consistently over long enough timescales, produce a cosmos that becomes progressively less hospitable to the kind of organized, energy-consuming, information processing structures that we call life and mind and experience. The universe does not care about this. That is perhaps the most important thing to understand, and the most difficult to fully absorb. The universe is not indifferent in the way that a person can be indifferent, choosing not to care about something they are aware of. The universe is indifferent in a more complete sense. It has no awareness of what it contains. It has no preference for complexity over simplicity, for light over darkness, for life over lifelessness. The laws of physics that produce the Big Bang and the cosmic web and the stars and the planets and the conditions for life are the same laws that are now, with perfect consistency and without any change of direction, producing the slow dissolution of all of those things. The universe is not turning against life, it never turned toward it. Life was a local, temporary consequence of particular initial conditions and particular physical laws, and it will be a local, temporary feature of the universe's history, not its destiny. Look up at the night sky one more time. The stars are still there. They are still beautiful. The beauty is real. It is not diminished by knowing what we know, but it is changed. It is the beauty of something temporary, something that exists in a particular window of cosmic time that will not always be open. The stars overhead are not the permanent furniture of the universe. They are the current phase of a process that began with the Big Bang and will end, after an almost incomprehensible duration, in cold and darkness and silence. They are the light of a fire that is burning down, and the fire is beautiful, and the fire is real, and the fire is going out. The Milky Way, that pale river of light that arches across the sky on a clear night, contains hundreds of billions of stars. Each one is a sun. Many of them have planets. Some of those planets may have conditions suitable for life. Some of them may already have life. Some of them may have civilizations looking up at their own night skies and feeling the same sense of wonder and fullness and presence that you feel when you look up at yours. And all of those stars, all of those planets, all of those possible civilizations are part of a galaxy that is itself aging, that is itself slowly running down its supply of star-forming gas, that is itself moving along the same trajectory that all galaxies follow, from bright and active and star-forming to old and red and quiet, and eventually dark. The Milky Way will merge with the Andromeda Galaxy in roughly 4.5 billion years. This collision will not be the catastrophe it might sound like. The stars are so far apart that very few will actually collide, but the merger will trigger a burst of new star formation as gas clouds are compressed by the gravitational disturbance, and then, when that burst is over, the combined galaxy will settle into a new shape, an elliptical galaxy, rounder and smoother than either of its predecessors, with most of its star-forming gas used up in the merger's burst of activity. The resulting galaxy, sometimes called Milkomeda by astronomers with a taste for portmanteau, will be older and quieter than either the Milky Way or Andromeda are today. It will be a galaxy in its late middle age, still containing billions of stars, but no longer the vigorous star-forming system that the Milky Way is now. And over the billions of years that follow, Milkomeda will age further. Its remaining gas will be consumed or expelled. Its massive stars will die in supernovae and leave behind neutron stars and black holes. Its sun-like stars will swell into red giants and shed their outer layers and cool to white dwarfs. Its red dwarfs will continue burning, slowly, for trillions of years, the last embers of a fire that once blazed across the entire galaxy. And gradually, over timescales that make the current age of the universe seem like a brief introduction, the galaxy will go dark, not all at once, not dramatically, but star by star, light by light. The galaxy will fade from a glowing structure visible across millions of light years to a collection of cold, dark remnants drifting through the darkness of intergalactic space. By the time the last red dwarfs in Milkomeda go out, the universe will be so old that the number of years elapsed will have more digits than there are atoms in the observable universe today. This is not hyperbole. It is a straightforward consequence of the physics of stellar evolution applied to the least massive, most long-lived stars. The universe will be ancient beyond any meaningful comparison, and it will be dark. Not the darkness of a night sky with stars, not the darkness of a room with the lights off, but a darkness that has no stars to interrupt it, no galaxies to provide a distant glow, no fires of any kind burning anywhere within the observable horizon. In that darkness, the remnants of what was once the Milky Way and Andromeda will drift, white dwarfs cooling toward black dwarfs, neutron stars, spinning down, their magnetic fields fading, their surfaces growing cold, rogue planets, ejected from their stellar systems by gravitational interactions over the long eons, drifting alone through the void with no sun to warm them and no orbit to define their path. And at the center of it all, the supermassive black hole that was once Sagittarius A and its counterpart from Andromeda, merged now into a single enormous black hole of tens of millions of solar masses, sitting in the darkness, radiating nothing visible, consuming nothing because there is nothing left to consume, simply existing in the cold and the silence, patient in a way that has no meaning because patience implies the passage of time, and time, in that era, will have become almost meaningless, but not quite, because even in that era, even in the darkness of the degenerate era, and the black hole era that follows it, time continues to pass. The universe continues to expand. The distances between the remnants of dead galaxies continue to grow. The thin radiation that fills the universe, the cosmic microwave background that is already cold and faint today, will have cooled further, stretched by the expansion to wavelengths so long they carry almost no energy. The universe will be colder than it is now, colder than it has ever been, approaching, asymptotically, the absolute zero of temperature, the point at which all thermal motion ceases and the universe reaches the stillness that entropy has been driving it toward since the beginning. And in that cold, in that stillness, in that darkness, the black holes will be evaporating, slowly, unimaginably slowly, radiating away their mass in the faintest possible trickle of Hawking radiation, growing infinitesimally smaller with each passing eon, taking timescales so vast that they make the stellar era look like a brief flash of light, but evaporating, losing mass, shrinking, and eventually, after a duration that no number written in ordinary notation can adequately represent, reaching the end of their evaporation in a final burst of radiation, a last gasp of energy from the last organized structure in the universe, and then gone. The black hole era will end not with a collapse but with a whisper, a final quantum of radiation emitted into a universe that is already so cold and so empty that the whisper will travel forever without being absorbed by anything, and then there will be nothing left but the radiation itself, the thin, cold, featureless sea of photons and other particles that represents the final state of all the matter and energy that ever existed in the universe. No structure, no gradients, no differences of temperature or density or composition that could drive any process or support any complexity. Just the uniform, cold, expanding expanse of a universe that has reached the end of its story. This is the heat death. This is the final condition toward which the laws of physics have been pointing since the first moment of the Big Bang. Not a dramatic ending, not a collapse or an explosion, just the slow, patient, inevitable approach to a state of maximum entropy, a state from which no further change is possible because all the differences that drive change have been erased. There is something in this that resists easy emotional processing. It is not grief exactly, because grief requires a loss that is felt, and there will be nothing left to feel the loss. It is not tragedy in the classical sense, because tragedy requires a protagonist who falls from a height, and the universe has no protagonist. It is something else, something closer to the feeling you get when you look at a photograph of a place that no longer exists, a city that was destroyed, a landscape that was changed beyond recognition, a face that belongs to someone who is gone. The photograph is real, the place was real, the person was real, but the reality they represent is over, and the photograph is all that remains. And eventually the photograph too will fade. The universe is that photograph. The stars and galaxies and cosmic web and all the complexity that has arisen within it are the image on the paper, and the paper is fading, not quickly, not in any way that is perceptible on human timescales, but fading, steadily, in the direction that entropy points toward a blankness that will eventually be complete. The image will not be preserved. There is no archive outside the universe where a copy is kept. There is no observer outside the cosmos who will remember what it looked like when it was full of light. When the last photon of Hawking radiation from the last evaporating black hole has traveled far enough that it will never interact with anything again, the universe will have forgotten itself entirely, and there will be no one left to remind it. And yet here we are. Here you are, standing under that sky, or sitting in a room lit by electricity generated by processes that trace back ultimately to the nuclear fire of a star. Here you are, a temporary arrangement of atoms that were forged in the cores of stars that died before the sun was born, atoms that have been part of gas clouds and rocky planets and oceans and living things and soil and air, and now, for this brief moment, are arranged into something that can look up at the night sky and wonder about it. The fact that this is possible, that the universe has produced in this particular corner of space and time something capable of asking questions about the universe, is not nothing, but it is also not a guarantee of anything. It is not evidence that the universe is moving toward greater complexity or greater awareness or greater meaning. It is evidence only that, under the right conditions for a limited time, complexity happens, and then it stops. The conditions that produced you are not the default conditions of the universe, they are the exception. The default condition of the universe is the void. The default condition is cold gas drifting through darkness, or no gas at all, just radiation thinning toward nothing as the expansion continues. The stars are the exception, the planets are the exception, the chemistry of life is the exception, the awareness that looks up at the night sky and feels wonder is the exception. And exceptions by definition do not last forever. They exist within a context that eventually reasserts itself. The context of the universe is emptiness, and it is patient, and it will wait, but it goes deeper, because the story of the universe's future is not just a story about physical processes happening on timescales too large to feel. It is a story about the nature of knowledge itself, about what it means to understand something, about the relationship between observers and the cosmos they inhabit, and this is where the narrative takes a turn that is, in some ways, more unsettling than anything that has come before, because the universe is not just becoming emptier and darker and colder, it is becoming less legible, it is becoming a place where the evidence needed to understand it is progressively less available, and this process is already underway. Consider what we know about the universe and how we know it. We know that the universe began in a hot, dense state, roughly 14 billion years ago, because we can detect the cosmic microwave background radiation, the faint afterglow of that early hot phase still filling the universe in every direction. We know the universe is expanding because we can measure the redshift of distant galaxies, the stretching of their light as the space between us and them grows. We know the large-scale structure of the cosmic web, because we have mapped the positions of millions of galaxies and found the pattern of filaments and voids. We know the age and composition of the universe because we can read these things from the light of distant objects, light that has been traveling toward us for billions of years and carries in its spectrum the record of conditions at the time and place it was emitted. All of this knowledge depends on light reaching us. It depends on the universe being old enough and the expansion being slow enough that the light from distant objects has had time to cross the intervening space and arrive at our telescopes. It depends on the cosmic microwave background still being detectable, still carrying the imprint of the early universe in its temperature fluctuations. It depends on the evidence still being present, still being accessible, still being readable, and all of these dependencies are temporary. The expansion is carrying the evidence away. The cosmic microwave background is cooling and stretching toward wavelengths that will eventually be undetectable. The distant galaxies are receding toward the horizon. The window through which we can read the history of the universe is open now, but it will not always be open. Astronomers have calculated that if a civilization like ours had arisen not 14 billion years after the Big Bang, but a trillion years after it, they would look out at a universe that appeared, by all available evidence, to be static, isolated, and eternal. The cosmic microwave background would have cooled and stretched beyond any plausible detection. The distant galaxies would have receded beyond the horizon. The local group, the small cluster of galaxies that includes the Milky Way and Andromeda, and a few dozen smaller companions, would appear to be the entire universe. There would be no redshift to measure, because all the galaxies outside the local group would be gone from view. There would be no cosmic microwave background to detect. There would be no evidence of the Big Bang, no evidence of cosmic expansion, no evidence that the universe had ever been anything other than this small, quiet, isolated collection of aging galaxies surrounded by darkness. A civilization in that era, no matter how intelligent, no matter how technologically advanced, would have no way of knowing what we know. They would have no way of discovering that the universe was once full of hundreds of billions of galaxies. They would have no way of measuring the expansion. They would have no way of detecting the Big Bang. The evidence would simply not be there, and they would construct their cosmology, their understanding of the universe, based on what was available to them, and that cosmology would be wrong in ways they could not detect and could not correct, because the data needed to correct it would be permanently beyond reach. This is not a hypothetical problem for some distant future civilization. It is a description of a real process that is already underway. We are already losing access to some of the universe's history. The most distant galaxies we can currently observe are already receding faster than light, already beyond the point where any new light they emit will ever reach us. We are seeing them as they were in the past when the light we are now receiving was emitted, but we will never see them as they are now, and we will never receive any signal they send from this moment forward. The horizon is already there. It is already cutting us off from part of the universe, and it is moving in the sense that more and more of the universe is crossing it as the expansion accelerates. There is a phrase that physicists use for this: the shrinking of the observable universe. Not the physical universe, which is expanding, but the observable universe, the region from which light can in principle reach us, which is shrinking as the expansion accelerates and more regions cross the horizon. The universe is getting larger and less knowable at the same time. It is expanding into a vastness that is increasingly beyond the reach of any observer within it. The cosmos is growing, and growing lonelier and growing darker and growing quieter all at once, all driven by the same underlying physics, all pointing in the same direction. And this leads to something more disturbing, because if the observable universe is shrinking, if the evidence of cosmic history is being carried away by expansion and scrambled by entropy, then the universe is not just becoming emptier in a physical sense, it is becoming emptier in an epistemic sense. It is becoming a place where less can be known, where fewer questions can be answered, where the story of the cosmos becomes progressively shorter and less detailed as the evidence for its earlier chapters disappears. The universe is editing its own history, and the editing is permanent. Think about what it means to know something about the distant past. It means that some record of that past has survived into the present. A fossil is a record of a living thing that existed millions of years ago. A light year is a record of a star that existed a year ago, or a million years ago, or a billion years ago, depending on how far away it is. The cosmic microwave background is a record of the universe as it was 380,000 years after the Big Bang. These records exist because the universe has been, up to now, a place where information can travel and persist. Light travels, fossils form. Patterns in the cosmic microwave background survive for billions of years. The universe has been, in this sense, a place with a memory. But memory requires a medium. It requires something that can carry information across time. And the universe's capacity to carry information across time is being degraded by the same processes that are degrading everything else. The expansion stretches and cools the light that carries information about distant events. Entropy scrambles the organized structures that encode information about the past. The horizon cuts off the signals from regions that have crossed it. The universe's memory is fading, and when it is gone completely, because there is no backup, no external storage, no place outside the universe where a copy of its history is preserved. We are living in the era when the universe's memory is still largely intact. We can still read the cosmic microwave background. We can still see the distant galaxies. We can still trace the large-scale structure of the cosmic web. We can still, in principle, reconstruct a significant portion of the history of the cosmos from the evidence that is currently available. This is an extraordinary privilege, though it does not feel like one because it is simply the condition we were born into. But it is a privilege that is time-limited. the universe is not going to remain this legible. It is going to become progressively harder to read, and eventually impossible to read, and eventually there will be nothing left to read, and nothing left to read it. But it gets worse, because the loss of cosmic memory is not just a problem for future civilizations trying to understand the universe. It is a problem for the universe itself, in the only sense in which the universe can be said to have problems, which is the sense in which the universe contains things that process information and are affected by the availability of that information. Life, in other words, consciousness, the capacity for experience and understanding that has arisen, at least once and possibly many times, within the universe's brief luminous era. The universe's memory is the only memory there is. When it fades, the past does not merely become inaccessible. It becomes, in the most complete sense, as though it never happened. This is the existential consequence that the entire narrative has been building toward, and it is worth sitting with it for a moment before moving on. The universe began, it evolved, it produced stars and galaxies and planets, and, in at least one case, life and consciousness, and the capacity to ask questions about the universe. And then, over an enormous but finite duration, it will erase all of this, not violently, not intentionally, but completely. The stars will go out, the galaxies will fade, the evidence of the universe's history will be carried beyond the horizon or scrambled by entropy. The last black holes will evaporate, the last particles will drift apart, and the universe will be left in a state that contains no record of anything that ever happened within it. No record of the stars, no record of the galaxies, no record of the life, no record of the questions that were asked or the answers that were found or the beauty that was perceived. The universe will have forgotten everything, and there will be nothing left to remember. And yet the questions were asked, the beauty was perceived, the stars burned, and their light crossed the void, and some of it fell on eyes that recognized it as beautiful. This happened. It is happening now. Whatever the ultimate fate of the universe, whatever the final condition of a cosmos that has spent all its fuel and erased all its records, the fact that this moment exists, the fact that the universe has produced, in this particular corner of space and time, something capable of looking up at the night sky and feeling the weight of all that light, is real. It is not diminished by the knowledge that it is temporary, but it is not made permanent by the fact that it is real. Temporary things are real. They are just temporary. The night sky you see tonight will not always look the way it looks tonight. This is not a metaphor. It is a straightforward consequence of the physics we have been tracing. The stars overhead are burning through their fuel. The nearest ones will last for billions of years, the red dwarfs for trillions, but they will go out. The Milky Way will merge with Andromeda, and the resulting galaxy will age and fade. The distant galaxies that you can see with a telescope, the ones that look like faint smudges of light in long exposure photographs, are already receding. Some of them are already beyond the horizon in the sense that no new light they emit will ever reach us. Over time, more will follow. The night sky will become darker, not in your lifetime, not in the lifetime of the sun, but on the timescale of the universe. The night sky is a temporary phenomenon. The darkness is the permanent condition. The light is the interruption. There is a thought experiment that captures something of this. Imagine a future observer, billions of years from now, in a universe where the expansion has carried all the galaxies outside the local group beyond the horizon. This observer looks up at the night sky and sees the stars of the merged Milky Way Andromeda galaxy, aging and reddening, and beyond them, darkness, no distant galaxies, no cosmic microwave background detectable with any instrument, no evidence of expansion, no evidence of the Big Bang, just the local stars growing older and the darkness beyond them. This observer has no way of knowing that the universe was once full of hundreds of billions of galaxies. They have no way of knowing that the darkness they see is not the natural state of the cosmos, but the result of a process that has been running for billions of years. They look up at the sky and see what appears to be a small, static, isolated universe, and they build their cosmology accordingly, and their cosmology is wrong, and they cannot know it is wrong, because the evidence that would correct it is gone. We are not that observer. We are the observer who still has access to the evidence. We are the observer who can still see the distant galaxies, still detect the cosmic microwave background, still measure the expansion, still read the history of the universe in the light that has been traveling toward us for billions of years. We are living in the window, and the window is open now, but it will not always be open. The universe is not waiting for us to finish our observations. It is not holding the evidence in place until we have understood it fully. It is moving, expanding, cooling, fading, carrying the evidence away at the speed of light and beyond, and the window is closing, slowly but without any possibility of reversal. This is not cause for despair in any simple sense. Despair implies that something could have been different, that there was a choice that was not made, a path that was not taken. The universe's trajectory is not a choice. It is a consequence of the laws of physics applied consistently from the beginning. There is no version of the universe in which the expansion does not accelerate, in which entropy does not increase, in which the stars do not eventually go out. The laws are what they are. The trajectory is what it is. And within that trajectory, within the enormous but finite window of the luminous era, the universe has produced something remarkable. It has produced the capacity to understand itself, at least partially, at least temporarily, and that capacity is being used right now to trace the arc of the universe's story from its bright beginning to its cold end, but it goes deeper, because understanding the arc of the universe's story does not change the arc. It does not slow the expansion or replenish the hydrogen or halt the increase of entropy. It does not extend the window or preserve the evidence or ensure that future observers will have access to what we know. Understanding is not intervention. Knowledge is not power over the laws of physics. We can trace the trajectory of the universe with extraordinary precision, and the trajectory does not care that we have traced it. The universe is indifferent to its own comprehension. It will follow its laws whether or not anything within it understands those laws. The stars will go out whether or not anyone is watching. And this is perhaps the deepest and most difficult thing to absorb about the universe as it actually is, as opposed to the universe as it feels when you stand under the night sky and look up at the stars. The universe does not need observers. It does not require witnesses. It does not produce complexity and consciousness because it is moving towards some state in which complexity and consciousness are the point. It produces them as a local, temporary consequence of particular physical conditions, and it will dissolve them as those conditions change, with the same indifference with which it produced them. The universe is not a story with a protagonist. It is a process with a direction, and the direction is not toward us. It is away from us, away from complexity, away from light, away from the conditions that make questions possible, toward the cold and the dark and the silence that are the universe's natural resting state. Look up at the night sky one more time. The stars are still there. They are still burning. The light is still crossing the void and falling on your eyes and producing in you the sensation of wonder that human beings have felt since before they had words for it. The universe is still in this moment, full enough of light to create that sensation. The Milky Way still arches overhead. The distant galaxies are still there, still visible, still sending their ancient light toward us across billions of light years of expanding space. The cosmic web still holds its shape, the filaments still glowing with the light of billions of stars, the void still dark and vast and dominant. The universe is still, in this particular moment of its history, a place where light exists and beauty is possible, and questions can be asked. But you know now what you did not know when you first looked up. You know that the fullness is an illusion, that the light is the exception, that the darkness is the rule. You know that the space between the stars is almost perfectly empty, and the space between the galaxies is emptier still, and the space inside the cosmic voids is the closest thing to nothing that nature produces. You know that the visible matter is only 5% of what is there, that the rest is dark and invisible and largely unknown. You know that the universe is expanding, accelerating, carrying the distant galaxies beyond the reach of any future observer. You know that the stars are burning through their fuel, that the rate of star formation is declining, that the universe is moving from its luminous era toward a long, dark future of cold remnants and evaporating black holes and thin radiation. You know that the universe's memory is fading, that the evidence of its history is being carried away by expansion and scrambled by entropy, that future observers will look out at a universe that appears to have no history because the history has been erased. And you know one more thing. You know that the night sky you see tonight is not the permanent condition of the cosmos. It is a snapshot of a particular moment in the universe's history, a moment that is already passing, a moment that will not come again. The stars overhead are not eternal. The galaxies are not permanent. The cosmic web is not a fixed structure. The light that fills the sky is not the natural state of the universe, but a temporary departure from it, a brief, luminous interval in a story that begins and ends in darkness. The universe was dark before the first stars ignited. It will be dark again after the last stars go out. The light is the middle, and the middle is where we are. There is something in this that is very difficult to name. It is not quite grief and not quite wonder and not quite fear. though it contains elements of all three. It is the feeling of standing at a particular point in a very long story and knowing, with some precision, where the story is going. It is the feeling of looking at something beautiful and knowing that the beauty is temporary, not in the vague philosophical sense in which all things are temporary, but in the specific physical calculable sense in which the fuel will run out and the lights will go dark and the distances will grow so large that nothing will be able to reach anything else. It is the feeling of being inside the window, knowing the window is closing, and not being able to do anything about it except look. And perhaps that is enough. Perhaps looking is enough. Perhaps the fact that the universe has produced in this brief, luminous interval something capable of looking at it and understanding it and feeling the weight of its beauty and its emptiness and its indifference is itself a kind of answer to the question that the universe's trajectory poses. Not a comforting answer, not a final answer, but an answer of a kind. The universe is mostly empty, mostly dark, mostly cold, mostly beyond reach, and yet here in this corner of it for this moment something is looking, something is asking, something is tracing the arc from the bright beginning to the cold end and feeling, in the tracing, something that the universe itself does not feel, and cannot feel, and will never feel, something that exists only in the window, only in the light, only in the brief interval between the first ignition and the final silence. But it gets worse, because even this, even the consolation of looking and asking and understanding, is subject to the same trajectory. The capacity for understanding is not exempt from the laws of physics. It depends on the same conditions that produce stars and planets and chemistry and life. It depends on energy gradients, on the availability of low-entropy fuel, on the existence of stable environments where complex processes can run for long enough to produce something like thought. And all of these conditions are temporary. The window for understanding is not just closing in the sense that the evidence is being carried away. It is closing in the sense that the conditions for understanding are themselves being degraded by the same processes that are degrading everything else. The universe is not just becoming less knowable, it is becoming less capable of producing knowers. This is the final turn of the screw, the deepest level of the unease that the universe's trajectory produces. It is not just that the universe will eventually be empty and dark and cold. It is that the emptiness and darkness and cold will be complete, in the sense that there will be nothing left to notice them. The universe will not be experienced as empty. It will not be felt as dark. It will not be known as cold. It will simply be those things without witness, without record, without any trace of the brief interval in which it was otherwise. The universe will have passed through its luminous era, the way a wave passes through water, leaving the water, after the wave has gone, exactly as it was before. The wave was real. The wave was beautiful. The wave is gone. There is a particular quality to the silence that follows that image. Not the silence of a room where someone has just stopped speaking, but the silence of a place where speaking has never occurred and never will. The silence of the intergalactic void, where the distance between any two particles is so large that the concept of sound, which requires a medium, which requires particles close enough to push against each other, has no meaning. The silence of the far future, where the last organized structures have dissolved and the last energy gradients have been smoothed away, and the universe has settled into the featureless equilibrium that entropy has been building toward since the first moment of the Big Bang. That silence is not dramatic. It is not the silence after an explosion or the silence after a death. It is the silence of a process completed, of a system that has reached its final state and has nothing left to do and nowhere left to go. But we are not there yet. And the distance between where we are and where the universe is going is itself a kind of story, a story that has not been fully told, a story whose middle chapters contain things that are worth understanding, not because they change the ending, but because they illuminate the nature of the process. The universe does not jump from its current luminous state to its final cold silence in a single step. It passes through phases, each one darker and quieter than the last, each one a further stage in the long unwinding of the complexity that the Big Bang set in motion. And each phase has its own character, its own particular quality of emptiness, its own way of being a universe that is less than what came before. The phase we are in now, the stelliferous era, the age of stars, has been running for roughly 14 billion years and will continue for trillions more. It is the era in which the universe is most active, most complex, most full of the kind of organized energy release that makes chemistry and life and thought possible. It is the era in which the cosmic web holds its shape, in which galaxies are still forming stars, in which the night sky is still populated by enough light to create the illusion of fullness. It is, by the standards of the universe's full timeline, an extraordinarily brief era, a thin bright band in a timeline that extends for duration so large that the stelliferous era occupies only the first infinitesimal fraction of it. After the stelliferous era ends, after the last stars have burned out and the galaxies have gone dark, the universe will enter the degenerate era. This is the era of stellar remnants, of white dwarfs cooling toward black dwarfs, of neutron stars spinning down in the darkness, of brown dwarfs that never quite ignited drifting cold and invisible through the void. It is an era that will last far longer than the stelliferous era, stretching across timescales measured in numbers with more zeros than can be written in the observable universe. During this era, the universe will still contain matter. It will still have structure in the loose sense that the remnants of dead galaxies will still be gravitationally associated, still drifting in rough proximity to each other. But it will be a structure without light, without energy, without the kind of organized activity that we associate with a living cosmos. And it goes deeper, because even during the degenerate era, even in the long, cold darkness after the stars have gone out, there will be occasional events. Gravitational interactions between stellar remnants will sometimes fling objects out of their host systems entirely, sending them on trajectories that will carry them away from their home galaxies forever. Rogue objects drifting alone through the intergalactic void. Sometimes two remnants will collide or merge, producing a brief flare of energy in an otherwise dark sky. Sometimes a white dwarf will accumulate enough mass from a companion to trigger a thermonuclear explosion, a last brief blaze of light in a universe that has otherwise gone dark. These events will be rare, separated by enormous intervals of time, but they will happen. The universe will not be completely inert during the degenerate era. It will simply be very, very quiet. But it gets worse, because even the matter that survives the degenerate era, even the cold, dark remnants of dead stars, may not be permanent. There is a theoretical possibility, not yet confirmed by observation, but consistent with certain extensions of the standard model of particle physics, that protons, the fundamental building blocks of atomic nuclei, are not stable over infinite timescales. If protons decay and the current experimental lower bound on the proton lifetime is enormous, more than 10 to the power of 34 years, then over sufficiently long timescales, all ordinary matter will dissolve. The white dwarfs and neutron stars and rogue planets and cold dark remnants of the degenerate era will not last forever. They will slowly, atom by atom, proton by proton, dissolve into lighter particles and radiation. The matter that survived the death of the stars will itself eventually die, not in any dramatic way, but in the quiet, patient, statistical way that quantum mechanics permits. Whether protons actually decay is not known with certainty. The experiments designed to detect proton decay have not yet seen it, which means either that protons are stable or that their lifetime is longer than the current experiments can probe. But even if protons are perfectly stable, even if ordinary matter persists indefinitely, the degenerate era will eventually give way to the black hole era, the phase in which the dominant structures in the universe are the supermassive black holes that were once the engines of galaxies. By the time the degenerate era ends, the stellar remnants will have been largely dispersed by gravitational interactions, scattered into the intergalactic void, or consumed by the black holes at the centers of dead galaxies. What remains will be the black holes themselves, drifting through the darkness, occasionally merging when their paths cross, growing slowly larger, waiting in the only sense that a physical object can wait, which is to say simply persisting, unchanged, in the cold and the silence. The black hole era will be the longest era in the universe's history by an enormous margin. It will stretch across timescales that make the stelliferous era and the degenerate era look like brief introductions. The supermassive black holes at the centers of large galaxies will take something on the order of 10 to the power of 100 years to evaporate completely through Hawking radiation. That number, 10 to the power of 100, is called a googol, and it is so large that it has no meaningful physical referent. The number of atoms in the observable universe is roughly 10 to the power of 80. The number of seconds since the Big Bang is roughly 10 to the power of 17. A googol is larger than either of these by factors that themselves have no meaningful physical referent. And yet the black hole era will last for something like a googol years, or longer, depending on the mass of the largest black holes. During the black hole era, the universe will be almost perfectly dark. The Hawking radiation emitted by black holes is extraordinarily faint, with a temperature inversely proportional to the mass of the black hole. A stellar mass black hole emits Hawking radiation at a temperature of about 100 millionth of a degree above absolute zero. A supermassive black hole emits it at a temperature so close to absolute zero that the difference is essentially unmeasurable. The universe during the black hole era will be colder than the cosmic microwave background is today, colder than anything that exists in the current universe, colder than any temperature that has been achieved in any laboratory on Earth. It will be a universe of almost perfect cold, almost perfect darkness, almost perfect silence, punctuated only by the unimaginably faint trickle of Hawking radiation from the black holes that are its only significant structures. And then, one by one, the black holes will finish evaporating. The smallest ones first, the stellar mass black holes that formed from the deaths of individual stars, then the larger ones, then the supermassive ones. Each evaporation will end in a brief burst of high-energy radiation, a final flash as the black hole's remaining mass is converted entirely to energy in its last moments. These flashes will be the last significant energy releases in the universe's history. After the last one, there will be nothing left but the thin, cold, featureless sea of particles and radiation that represents the universe's final state. Photons, neutrinos, electrons, positrons, all moving apart from each other at the speed of light or close to it, in a universe so large and so cold that the probability of any two of them ever interacting again is effectively zero. The universe will have reached its final state, maximum entropy, heat death, the end of the story. But there is a question that this endpoint raises, a question that is not scientific in the conventional sense, but that the scientific picture makes unavoidable. What does it mean for something to have happened if all record of it is eventually erased? What does it mean for the stars to have burned, for the galaxies to have formed, for life to have arisen and looked up at the night sky and wondered if the universe will eventually reach a state in which none of this has left any trace? Is the past real in any meaningful sense if it is completely inaccessible? Is an event that happened and left no record the same as an event that never happened? These are not questions that physics can answer. Physics can tell us that the events happened, that the stars burned and the galaxies formed and the life arose, because we are here now, and we can observe the evidence. But physics cannot tell us whether the happening of an event, in the absence of any record or witness, constitutes a kind of reality that persists after the evidence is gone. This is a question about the nature of time and existence and meaning that goes beyond what equations can resolve, and the universe, characteristically, offers no guidance. It simply proceeds along its trajectory, indifferent to the questions it raises in the minds of the temporary arrangements of matter that it has produced. There is a way of thinking about this that is not comforting but is, perhaps, honest. The universe does not owe us permanence. It does not owe us meaning. It does not owe us a record that persists, or a future that remembers, or a structure that endures. The universe is what it is, and what it is includes the fact that it produces complexity and then dissolves it, that it creates conditions for understanding and then removes them, that it generates beauty and then erases it. This is not a flaw in the universe. It is not a tragedy in the sense of something that went wrong. It is simply the nature of a physical system governed by the laws of thermodynamics, playing out over timescales that dwarf anything that has ever been called history. And yet the beauty was real. This is the thing that is hardest to hold on to and most important not to let go of. The beauty was real. The stars that burned for billions of years were real. The galaxies that formed along the filaments of the cosmic web were real. The planets that orbited those stars were real. The chemistry that arose on at least one of those planets and produced living things was real. The awareness that arose in those living things and looked up at the night sky and felt the weight of all that light was real. None of this is diminished by the fact that it is temporary. None of it is made less real by the fact that it will eventually leave no trace. It happened. It is happening. And the happening is not nothing, even if the record of the happening will eventually be gone. But it goes deeper, because the reality of the beauty does not resolve the unease that the universe's trajectory produces. It coexists with it. The beauty is real, and the trajectory is real, and both of these things are true at the same time, and they do not cancel each other out. The stars are beautiful and they are going out. The galaxies are majestic and they are separating. The cosmic web is vast and it is dissolving. The universe is full of light and it is becoming empty. These are not contradictions to be resolved. They are the actual condition of the cosmos, held in tension, neither one canceling the other, both of them true simultaneously. This tension is what the night sky actually contains, if you know how to look at it. Not just the beauty of the light, but the knowledge of what the light is and where it is going. Not just the wonder of the stars, but the understanding of what the stars are doing and how long they will last. Not just the sense of fullness that the sky produces, but the awareness of the emptiness that the fullness is floating in, the vast, dark ocean of void and dark matter and dark energy that surrounds and permeates and ultimately dominates the luminous structures that catch the eye. The night sky is not just beautiful, it is beautiful and temporary, and surrounded by darkness and moving towards silence. And knowing all of this does not make it less beautiful, it makes it something else, something more complicated, something that requires a different kind of looking. The kind of looking that takes in not just the light, but the darkness, not just the stars, but the void between them, not just the galaxies, but the enormous empty regions that define the true geometry of the cosmos, not just the present moment of the universe's luminous era, but the full arc of its history and its future, from the hot, dense beginning to the cold, thin end. The kind of looking that does not flinch from the scale of the emptiness or the length of the silence or the completeness of the eventual erasure. The kind of looking that holds the beauty and the indifference together, without resolving the tension between them, without pretending that one cancels the other. This is what the universe actually asks of us, if it can be said to ask anything. Not that we find comfort in its scale, not that we derive meaning from its complexity, not that we feel special because it produced us, but that we look at it honestly, with the full weight of what we know, and see it for what it is. A physical system of extraordinary scale and complexity, governed by laws that are indifferent to the structures they produce, moving in a direction that leads away from complexity and toward simplicity, away from light and toward darkness, away from the conditions that make questions possible and toward a final state in which no questions are possible, because there is nothing left to ask them. And this leads to something more disturbing. Because looking honestly at the universe, seeing it for what it is rather than what we wish it were, is itself a temporary capacity. The ability to look honestly, to understand the arc of cosmic history, to trace the trajectory from the Big Bang to the heat death, depends on the same conditions that produce all other forms of complexity. It depends on stars and planets and chemistry and life, and the particular kind of nervous system that produces the capacity for abstract thought. And all of these conditions are, as we have established, temporary. The honest looking is itself part of the luminous era. It will not survive the era's end. The universe will not be honestly looked at in the black hole era, because there will be nothing left to look. The honest looking is happening now in this window, and the window is closing. There is something almost unbearable about this, if you let yourself feel it fully. Not the fact of the universe's eventual cold end, which is distant enough to feel abstract, but the fact that the capacity to understand that end, the capacity to trace the arc and feel the weight of it, is itself subject to the same trajectory. The understanding is temporary. The looking is temporary. The wonder is temporary. Everything that makes the universe feel significant, everything that gives the night sky its weight and its beauty, and its capacity to produce in a human being the sensation of standing at the edge of something vast, is a product of the luminous era. And the luminous era is finite, and when it ends, the significance ends with it, not because significance was never real, but because significance requires a mind to hold it, and minds require conditions that the universe is in the process of removing. But it gets worse, because even within the luminous era, even now, the universe is not evenly hospitable to the kind of complexity that produces understanding. The vast majority of the universe, even now, even in the brightest phase of its history, is hostile to life. The cosmic voids are empty of the matter needed to form stars and planets. The intergalactic medium is too thin and too cold to support chemistry. The regions between galaxies are too far from any energy source to maintain the temperature gradients that life requires. Even within galaxies, most of the volume is too empty, too cold, too far from a stable star to support the conditions for biology. Life, if it exists elsewhere in the universe, is confined to the surfaces of planets orbiting stable stars. Tiny islands of warmth and chemistry, in an ocean of cold and emptiness that stretches in every direction for distances that make the islands themselves seem like rounding errors. We are on one of those islands. The Earth is a warm, wet, chemically complex surface orbiting a stable middle-aged star in the outer arm of a spiral galaxy that is itself one of hundreds of billions of galaxies in the observable universe. By the standards of the cosmos, the Earth is extraordinarily unusual, not because it is the only place where life exists. Perhaps it is not. Perhaps life has arisen on thousands or millions of other planets in other galaxies, but because the conditions it represents, the warmth, the liquid water, the chemical complexity, the stable energy source, are rare in a universe that is mostly cold and empty and chemically simple. The Earth is an exception to the rule of the cosmos. And exceptions, as we have established, do not last forever. The sun will eventually exhaust its hydrogen and expand into a red giant, and when it does, the Earth will be consumed or rendered uninhabitable. This will happen in roughly 5 billion years, a timescale so long that it is difficult to feel as a threat, but a timescale that is finite, that has a specific endpoint that is not negotiable. The Earth is not permanent. The conditions that make it habitable are not permanent. The warmth and the water and the chemistry are borrowed from a star that is burning through its fuel, and when the fuel runs out, the borrowing ends. The island will be submerged, the warmth will be gone, and whatever has been living on the island, whatever has been looking up at the night sky and wondering about the universe will have to have found somewhere else to go, or will be gone, and somewhere else to go is not guaranteed. The universe is large, but it is not infinitely hospitable. The conditions for life, as far as we understand them, require a particular combination of circumstances that becomes rarer as the universe ages. The rate of star formation is declining. The supply of hydrogen is being depleted. The galaxies are aging, and their star-forming regions are quieting down. The universe is not producing new islands of warmth and chemistry at the same rate it once did. The future is not a universe full of new opportunities. It is a universe with a declining inventory of the conditions that make opportunities possible. This is the context in which the night sky should be understood, not as a backdrop to human history, not as a permanent feature of reality, not as evidence that the universe is full and alive and generous with its light, but as a snapshot of a particular phase in the universe's evolution, a phase that is already past its peak, a phase that is moving, slowly but without reversal, toward its end. The stars overhead are the current inventory of a universe that is spending its resources. The light that falls on your eyes is the output of a process that has been running for 14 billion years and will run for trillions more, but that has a finite supply of fuel and a fixed direction of travel. The beauty is real, the light is real, and the light is going out. Not tonight, not in any human lifetime, not in the lifetime of the sun, but going out, in the way that all fires go out when the fuel is consumed, in the way that all organized systems tend toward disorder when left to run long enough, in the way that the laws of thermodynamics, applied consistently and without exception, produce a universe that moves from complexity to simplicity, from light to darkness, from the brief luminous interval of the stelliferous era to the long cold silence of the heat death. The direction is fixed. The destination is known. The only question is how long the journey takes, and the answer is longer than any number that has ever been used to describe anything in human experience, but not infinite, not forever, just very, very long. And in that very long journey, in that enormous stretch of time between now and the final silence, there will be moments. There will be stars igniting in the remaining gas clouds of aging galaxies. There will be planets forming around those stars. There will be perhaps chemistry arising on some of those planets, and life arising from that chemistry, and awareness arising from that life, and questions arising from that awareness. There will be perhaps other beings on other worlds, looking up at their own night skies and feeling the same weight of light that you feel when you look up at yours. There will be perhaps other moments of honest looking, other tracings of the arc from the bright beginning to the cold end, other instances of the universe briefly understanding itself through the temporary arrangements of matter that it has produced. These moments will not change the trajectory. They will not slow the expansion or replenish the hydrogen or halt the increase of entropy. They will be local, temporary, fragile departures from the universe's dominant condition of emptiness and indifference. But they will be real, they will be happening, and the happening will be, in the only sense that the word can be used honestly in this context, enough. Not enough to matter to the universe, which does not have a concept of mattering, but enough to be real, enough to be the thing that the universe has produced in its brief luminous interval, enough to be the answer, however temporary and however fragile, to the question of what the universe is for, except that the universe is not for anything. This is the final thing to understand, and the hardest. The universe does not have a purpose. It does not have a direction in the sense of a goal. It has a direction in the sense of a trajectory, a path determined by the laws of physics and the initial conditions of the Big Bang, a path that leads from the hot, dense beginning through the luminous era of stars and galaxies to the cold, thin end of maximum entropy. But this trajectory is not aimed at anything. It is not building toward anything. It is not the means to any end. It is simply what happens when the laws of physics are applied to the initial conditions of the Big Bang and left to run for a very long time. The night sky is beautiful. The stars are real. The galaxies are majestic. The cosmic web is vast and strange, And unlike anything that human intuition would have predicted, the dark matter is real, shaping the universe with its invisible gravity. The dark energy is real, driving the expansion that will eventually isolate every galaxy from every other. The entropy is real, moving the universe steadily toward its final cold state. The heat death is real, waiting at the end of a timeline so long that it makes the current age of the universe look like the first breath of a very long story. All of this is real, and none of it is for us. None of it is aimed at us. None of it is shaped by our presence or altered by our understanding or preserved by our wonder. We are here because the conditions were right. We are here because the universe, in this particular corner of space and time, happened to produce the conditions for chemistry and life and thought. We are here because the laws of physics, applied to the initial conditions of the Big Bang, produced, among other things, us. And we will be gone eventually because the same laws applied to the same universe will eventually remove the conditions that produced us. The universe did not intend us. It will not mourn us. It will not remember us. It will simply continue along its trajectory, indifferent to our presence and our absence alike, moving toward the cold and the dark and the silence that are its natural resting state. And yet here we are, looking up, asking questions, tracing the arc, feeling the weight of the light and the weight of the darkness and the weight of the distance between them. Here we are, in the window, while the window is open, doing the only thing that the window makes possible, seeing. Not just the stars, but the emptiness between them. Not just the light, but the darkness that surrounds it. Not just the present moment of the universe's luminous era, but the full arc of its history and its future, from the first ignition to the final silence. Seeing it honestly, seeing it whole, seeing it for what it is, which is vast and indifferent and temporary, and in this moment, still full enough of light to be beautiful. The seeing is not neutral. This is something worth understanding before we go any further into the dark. When you look at the night sky with the full weight of what we know, when you hold in your mind simultaneously the beauty of the light and the vastness of the emptiness and the direction of the trajectory, something happens that is not purely intellectual. Something shifts in the way the sky feels. The stars do not look the same after you know what they are doing. The darkness between them does not feel the same after you know how much of it there is and how much more of it there will be. The act of seeing the universe honestly changes the experience of seeing it. And this change is not a loss exactly, but it is not a gain in any simple sense either. It is a deepening, a complication, a movement from the comfortable illusion of a full and permanent sky to something harder and stranger and more true. The comfortable illusion is understandable. It is, in a sense, the natural response to the night sky, the response that human beings have been having for as long as there have been human beings. The sky looks full. The stars look permanent. The universe looks like a place that was made for looking at, a backdrop designed to inspire wonder and a sense of belonging. This is the illusion that the selection effect produces, the illusion that arises because we notice the rare things that shine and do not notice the overwhelming emptiness between them. It is a deeply human illusion, rooted in the way our eyes and our minds are built, in the way we are drawn to light and pattern and the sense of being surrounded by something alive. But the universe was not designed to be looked at. It was not arranged to produce wonder in the minds of the creatures it happened to generate. The cosmic web did not form along its filaments because the filaments would look beautiful in a telescope image. The stars did not ignite because their light would fall on eyes that would find it meaningful. The galaxies did not gather into clusters because the clusters would give future observers a sense of cosmic community. These things happened because the laws of physics, applied to the initial conditions of the Big Bang, produced them. The beauty is a consequence, not a purpose. The wonder is a byproduct, not a goal. The universe is not performing for us. It is simply doing what the laws of physics require it to do, and we are here briefly to notice. And the noticing matters, in the only way that anything can matter in a universe without inherent purpose, which is that it is happening. The noticing is real. The wonder is real. The questions are real. The tracing of the arc from the bright beginning to the cold end is real. These things are occurring in this moment, in this corner of the universe, and their occurrence is not diminished by the fact that the universe does not require them or preserve them or care about them. They are part of what the universe has produced in its luminous era. They are part of the inventory of the window, and the window is open now, but it goes deeper, because the noticing is not just a passive reception of information. It is an active engagement with the universe's own structure. When we trace the arc of cosmic history, when we measure the expansion and map the cosmic web and calculate the timescale of stellar evolution and derive the temperature of Hawking radiation from black holes that will not finish evaporating for a Google years. We are doing something that the universe has never done before in its 14 billion year history, as far as we know. We are the universe becoming aware of itself. Not in a mystical sense, not in a sense that implies the universe intended this or was building toward it, but in the straightforward physical sense that the matter of the universe has, in this corner of space and time, arranged itself into structures capable of modeling the universe and understanding its own nature. This is genuinely extraordinary, not because it makes us special in a cosmic sense, not because it implies that the universe has a purpose that we fulfill, but because it is an extraordinary thing for matter to do. The atoms in your body were forged in the cores of stars that died before the sun was born. They have been part of gas clouds and rocky planets and oceans and living things. And now, for this brief moment, they are arranged into something that can look up at the night sky and understand, with some precision, what the night sky is and where it is going. The matter of the universe is looking at itself. The universe is, through the temporary arrangement of some of its atoms, tracing its own trajectory. This is not nothing. It is, in fact, one of the most remarkable things that has ever happened in the 14 billion year history of the cosmos, and it is temporary. This is the thing that the remarkableness cannot escape. The self-awareness of the universe, the capacity of matter to model itself and understand its own nature, is a product of the luminous era, and the luminous era is finite. When the stars go out and the conditions for life are removed, the universe will lose this capacity. It will revert to being a physical system that proceeds along its trajectory without any internal model of itself, without any awareness of what it is or where it is going, without any experience of its own beauty or its own emptiness or its own indifference. The universe will become again purely physical, purely mechanical, purely the playing out of laws that have no witness and no interpreter. This is the loss that is hardest to articulate and most important to feel. Not the loss of the stars, which are beautiful but which the universe will not miss. Not the loss of the galaxies, which are majestic but which the universe will not mourn. But the loss of the looking, the loss of the capacity to trace the arc, the loss of the brief, fragile, extraordinary phenomenon of matter understanding itself. When the last mind goes dark, the universe will not notice. It will not register the loss. It will simply continue along its trajectory as it always has, as it always will, indifferent to the presence and absence of the awareness that briefly inhabited it. And this leads to something more disturbing, because the loss of the looking is not just a future event, it is a process that is already underway, in the sense that the conditions for the looking are already being degraded. The expansion is already carrying the evidence away. The entropy is already scrambling the organized structures that support complexity. The rate of star formation is already declining. The universe is already, in the most literal physical sense, moving away from the conditions that produce minds. The trajectory is fixed. The direction is clear. And the direction is away from awareness, away from understanding, away from the capacity to ask questions about the universe and feel the weight of the answers. There is a particular image that captures something of this, though no image can fully contain it. Imagine a candle burning in a very large, very dark room. The candle is small. The room is enormous. The candle's light reaches only a tiny fraction of the room's total volume, illuminating a small sphere of space around itself and leaving the rest in darkness. The candle is burning down. It has been burning for a long time, and it has a finite amount of wax, and when the wax is gone, the light will go out and the room will be dark again. While the candle burns, the small sphere of illuminated space is real. The light is real. The warmth is real. The shadows that the light casts on the nearby walls are real. But the room is mostly dark, and the darkness is patient, and the candle is burning down. The universe is that room. The luminous era is the candle. The stars and galaxies and planets and life and awareness are the light and warmth and shadows that the candle produces while it burns. And the darkness is not waiting for the candle to go out. The darkness is simply there, as it has always been, as it will always be, occupying the overwhelming majority of the room's volume, patient in the way that darkness is patient, which is to say simply present, simply the default condition of a room that has no permanent source of light. But it gets worse, because the candle is not just burning down. The room is also expanding. The walls are moving outward, slowly but continuously, driven by the same force that is driving the galaxies apart. And as the room expands, the darkness grows. Not because the candle is burning faster, but because the volume of darkness is increasing faster than the light can fill it. The candle's light reaches a fixed distance, determined by the speed of light and the rate of expansion. and beyond that distance, the darkness is absolute, and the distance is growing. The sphere of illuminated space is not keeping up with the expanding room. The darkness is winning, not by extinguishing the candle, but simply by growing faster than the light can reach. This is the actual situation of the universe. The luminous structures, the stars and galaxies and the cosmic web, are real and present and beautiful, but they are surrounded by an expanding darkness that is growing faster than the light can fill it. The observable universe, the sphere of space from which light can in principle reach us, is not expanding as fast as the universe itself. The darkness beyond the horizon is growing. The fraction of the universe that is, in principle, accessible to any observer, is shrinking. The candle is burning in a room that is getting larger, and the darkness is winning by geometry alone, without needing to extinguish anything. And when you hold this image in your mind, when you feel the full weight of it, the night sky looks different. Not darker, not immediately. The stars are still there. The Milky Way still glows. But the sky has a different quality. It has the quality of something that is happening against a background of something much larger and much darker, and much more permanent. The stars are not the universe. They are the exception to the universe. They are the brief, local, temporary departure from the universe's dominant condition, which is emptiness and darkness and cold. And they are beautiful precisely because they are exceptions, precisely because they exist against the background of the dark, precisely because the light is not the default but the departure. The departure is what we are. Every living thing on this planet, every mind that has ever looked up at the night sky and wondered, every civilization that has ever built a telescope or written a poem about the stars, or tried to understand the nature of the cosmos, is part of the departure. We are the exception. We are the candle. We are the brief, local, temporary arrangement of matter that is managed, against the overwhelming tendency of the universe toward disorder and darkness, to organize itself into something that can look at the universe and understand it. And we are burning down, in the way that all candles burn down, in the way that all exceptions eventually give way to the rule. This is not a reason for despair. It is not a reason for anything in the sense that the universe does not provide reasons, but it is a reason, in the human sense, for a particular kind of attention, for looking at the night sky with the full weight of what we know, for holding the beauty and the indifference together, without resolving the tension, for understanding that the light overhead is temporary and the darkness is permanent, and both of these things are true simultaneously, and neither one cancels the other, for being, while we are here, fully here, for asking the questions that the window makes possible, while the window is open, because the window will not always be open. This is the thing that the entire arc of the universe's story has been building toward, the thing that the emptiness and the dark matter and the dark energy and the expansion and the entropy and the heat, death all point to, the thing that is hardest to hold in the mind and most important, not to look away from. The window will close, not tonight, not in any human lifetime, not in the lifetime of the sun, but it will close. The stars will go out, the galaxies will fade, the evidence of the universe's history will be carried beyond the horizon or scrambled by entropy. The conditions for life and thought and wonder will be removed, the looking will end, and the universe will continue, dark and cold and indifferent, for a duration so vast that the entire luminous era, all 14 billion years of it, and all the trillions of years still to come, will be a rounding error in the total timeline of the cosmos. A rounding error. This is perhaps the most unsettling way to think about the luminous era, about the age of stars and galaxies and life and awareness, not as the main event of the universe's history, but as a brief anomaly in a timeline dominated by darkness. The universe will spend the overwhelming majority of its existence in states that contain no stars, no galaxies, no life, no awareness. The stelliferous era, for all its billions and trillions of years, is a thin, bright band in a timeline that extends for durations measured in googles of years. The darkness before the first stars and the darkness after the last black hole evaporates are not the margins of the universe's story. They are the story. The light is the footnote, and yet the footnote is where we live. The footnote is where everything that has ever been called significant has occurred. The footnote is where the stars burned and the galaxies formed and the planets coalesced, and the chemistry of life arose and the awareness that looks up at the night sky and wonders came into being. The footnote is where the questions are asked, and the answers are found and the beauty is perceived and the weight of the darkness is felt. The footnote is, in the only sense that the word can be used honestly, everything. Not everything in the cosmic sense, not everything in the sense of the universe's total content or total duration, but everything in the sense of everything that has ever mattered to anything that has ever been capable of mattering. And the footnote is ending, slowly, imperceptibly on any human timescale, but ending in the direction that the laws of physics point, toward the cold and the dark and the silence that are the universe's natural resting state. The stars are burning down. The galaxies are aging. The rate of star formation is declining. The expansion is accelerating. The horizon is drawing inward. The evidence is being carried away. The window is closing. And the darkness, patient and vast and permanent, is waiting on the other side of the window, as it has always been waiting, as it will always be waiting for the light to go out. Look up at the night sky one final time, not with the comfortable illusion of a full and permanent universe, not with the sense of being surrounded by something alive and generous and made for looking at, but with the full weight of what we know, with the knowledge that the light you see is the exception, and the darkness is the rule, with the knowledge that the space between the stars is almost perfectly empty, and the space between the galaxies is emptier still, and the space inside the cosmic voids is the closest thing to nothing that nature produces, with the knowledge that the visible matter is 5% of what is there, and the rest is dark and invisible and largely unknown, with the knowledge that the universe is expanding, accelerating, carrying the distant galaxies beyond the reach of any future observer, with the knowledge that the stars are burning through their fuel, that the galaxies are aging, that the rate of star formation is declining, that the universe is moving from its luminous era toward a long dark future of cold remnants and evaporating black holes and thin radiation and final silence. Look at the stars with all of this. Feel the weight of the emptiness that surrounds them. Feel the scale of the darkness that they are floating in. Feel the direction of the trajectory that the universe is following, away from light and toward darkness, away from complexity and toward simplicity, away from the conditions that make questions possible and toward a final state in which no questions are possible because there is nothing left to ask them. Feel all of this, and then look at the stars again, and notice that they are still beautiful. Notice that the beauty has not been diminished by the knowledge. Notice that the light is still real, still crossing the void, still falling on your eyes, still producing in you the sensation that human beings have felt since before they had words for it. The beauty and the indifference coexist. The light and the darkness coexist. The wonder and the unease coexist. This is the actual condition of the cosmos, and it is not a condition that resolves into something comfortable, or something hopeful, or something that makes the universe feel like a place that was made for us. It is a condition that simply is, that holds its contradictions without resolving them, that offers no comfort and no despair but only the full, complicated, slightly disturbing truth of what the universe actually is. What the universe actually is this: mostly empty, mostly dark, mostly cold, mostly beyond reach, mostly made of things we cannot see, shaped by forces we cannot fully understand, moving in a direction that leads away from everything we value and toward a final state that contains nothing we recognize. And within this overwhelming dominance of emptiness and darkness and cold, there is a thin luminous trace, a brief interval of stars and galaxies and planets and chemistry and life and awareness. A window, open now, closing slowly, through which the universe briefly looks at itself and finds it beautiful and strange and vast and slightly terrifying. We are that window. We are the looking. We are the brief, fragile, extraordinary phenomenon of matter understanding itself, of the universe producing, in one small corner of its enormous indifferent expanse, something capable of tracing its own arc from the bright beginning to the cold end. And we are temporary, not in the vague philosophical sense in which all things are temporary, but in the specific, physical, calculable sense in which the fuel will run out, and the conditions will change, and the window will close, and the looking will end. We are temporary in the way that the stars are temporary, in the way that the galaxies are temporary, in the way that the entire luminous era is temporary. We are part of the footnote, and the footnote is ending, but it has not ended yet. This is the only thing that can be said with confidence, the only thing that the universe's trajectory leaves intact. It has not ended yet. The stars are still burning, the galaxies are still there, the window is still open, the looking is still possible, the questions are still being asked, the beauty is still real. The light is still crossing the void and falling on eyes that recognize it as beautiful, and the recognition is real, and the beauty is real, and the light is real, and the void is real, and all of it, the light and the void and the beauty and the indifference and the temporary and the permanent, all of it is happening right now in this moment in this corner of the universe while the window is open. And this is where the story of the universe, told honestly, without comfort and without despair, arrives. Not at a conclusion that resolves the tension, not at a revelation that makes the indifference feel like love, or the emptiness feel like fullness, or the trajectory feel like progress, but at a moment of clear seeing, a moment in which the universe is seen for what it is, in all its scale and all its emptiness and all its beauty and all its indifference, without flinching and without pretending, a moment in which the looking is happening, fully and honestly, while the looking is still possible. The night sky is not permanent, the stars are not eternal, the galaxies are not fixed, the cosmic web is not a final structure, the light is not the default condition of the universe, the darkness is, and the darkness is patient, and the darkness is vast, and the darkness is coming, slowly and without any possibility of reversal, for everything that the light has briefly illuminated, for the stars and the galaxies and the planets and the chemistry and the life and the awareness and the questions and the beauty and the wonder, and the weight of all that light falling on all those eyes that have ever looked up at the night sky and felt for a moment that the universe was full. It was never full. It only looked that way from inside the window. From outside the window, from the perspective of the universe's total timeline and total volume, the light was always the exception. The darkness was always the rule. The window was always temporary, and the looking was always going to end. But it gets worse, because the ending of the looking is not the worst thing. The worst thing, the thing that sits at the bottom of the entire descent we have been making through the emptiness and the dark matter and the dark energy and the expansion and the entropy and the heat death, is not that the looking will end. It is that when it ends, it will end completely. There will be no record. There will be no memory. There will be no trace in the final cold state of the universe of the fact that the looking ever happened. The stars will have burned, and the galaxies will have formed, and the life will have arisen, and the awareness will have looked up at the night sky and felt the weight of all that light, and then the universe will have erased all of it, completely and permanently, and continued along its trajectory as though none of it had ever occurred. The universe will not remember the stars. It will not remember the galaxies. It will not remember the life. It will not remember the questions or the answers or the beauty or the wonder. It will not remember us. Not because it forgot, but because it never had the capacity to remember. Memory requires a structure that persists, a medium that carries information across time. And the universe's final state, the cold, thin, featureless expanse of maximum entropy, contains no such structure. It is, by definition, the state in which all information has been maximally dispersed, all records have been maximally scrambled, all traces of the past have been maximally erased. The heat death is not just the end of the universe's activity, it is the end of the universe's history, in the sense that history requires a record, and the record will be gone. This is the final condition. Not darkness in the poetic sense, not silence in the metaphorical sense, but the literal physical state of a universe that has reached maximum entropy. A universe in which the temperature is as close to absolute zero as it is possible to get. A universe in which the density of matter and energy is as close to zero as it is possible to get. A universe in which the distances between any two particles are so large that the probability of interaction is effectively zero. A universe that is, in the most complete and literal sense, empty. Not empty of matter entirely perhaps, but empty of the differences, the gradients, the organized structures, the energy flows that make anything happen. A universe in which nothing happens because there is nothing left to drive any process, because all the fuel has been spent and all the gradients have been smoothed and all the organized structures have dissolved into the featureless equilibrium that entropy has been building toward since the first moment of the Big Bang. And in that final state, in that cold and empty and silent expanse, there will be no one to look up. There will be no night sky, because there will be no stars to populate it and no planets to stand on and no eyes to look. There will be no wonder, because wonder requires a mind, and minds require conditions that will no longer exist. There will be no questions, because questions require a questioner, and questioners require the kind of organized complexity that the universe will have long since dissolved. There will be nothing that recognizes the universe as beautiful or vast or indifferent or temporary or permanent. There will be nothing that feels the weight of the darkness or the scale of the emptiness or the direction of the trajectory. There will be nothing that knows the universe exists. The universe will exist in its final cold state, without any internal witness, without any awareness of itself, without any experience of its own condition. It will simply be what it is, as it has always been, as it will always be, indifferent to its own existence in the way that only a physical system without awareness can be indifferent, and this is where the descent ends. Not with a revelation that makes the indifference feel meaningful, not with a conclusion that transforms the emptiness into something comforting, not with a final image that softens the cold or warms the dark or fills the silence with something that sounds like hope, but with the clear, unvarnished, slightly disturbing truth of what the universe is and where it is going. The universe is mostly empty. It is mostly dark. It is mostly cold. It is mostly beyond reach. It is moving, inexorably, and without any possibility of reversal, toward a final state of maximum entropy in which nothing happens, and nothing is remembered, and nothing is known. And within this trajectory, within this enormous and indifferent process, there is a brief, luminous interval in which stars burn and galaxies form and life arises, and awareness looks up at the night sky and wonders, and the wondering is real, and the beauty is real, and the light is real, and none of it will last. The night sky you see tonight is a gift that the universe did not intend to give. It is a consequence of particular initial conditions and particular physical laws, a temporary departure from the universe's dominant condition of emptiness and darkness. It will not always be there. The stars will go out, the galaxies will fade, the window will close, and the darkness, patient and vast and permanent, will reclaim what the light briefly held, not violently, not dramatically, but completely, and without any memory of what it held. Look up while you can, not because looking changes anything, not because the looking will be remembered or the beauty will be preserved, or the questions will be answered in any final sense, but because the window is open now and the light is real now and the universe is in this moment still full enough of stars to create the illusion of fullness, still warm enough in this small corner to support the kind of matter that can look up and wonder, still early enough in its long decline that the night sky is populated by enough light to be beautiful. Look up while the window is open. Feel the weight of the light. Feel the scale of the darkness that surrounds it. Feel the direction of the trajectory and the patience of the void and the temporary nature of everything that shines. And then consider this. Somewhere in the universe, right now, in some galaxy along some filament of the cosmic web, around some star that has not yet been named by any civilization, on some planet that has not yet been found by any telescope, there may be something looking up, something that has arisen from the chemistry of that planet and the light of that star, and the particular conditions of that corner of the cosmos, something that looks up at its own night sky and feels, in whatever way it is capable of feeling, the same weight of light that you feel when you look up at yours, something that is, like you, a temporary arrangement of matter in a universe that did not intend it and will not remember it, something that is, like you, inside the window, something that is, like you, part of the brief luminous interval between the first ignition and the final silence, and that something, wherever it is, whatever it is also looking at a sky that will not last, is also standing in a window that is closing, is also part of a universe that is mostly empty and mostly dark and mostly cold and mostly beyond reach, is also, in the only sense that the word can be used honestly in this context, alone. Not alone in the sense of being the only thing in the universe, but alone in the sense that the distances between things are so large, and the expansion is so relentless, and the horizon is so close, that the universe is becoming, for every observer within it, a smaller and smaller and lonelier place. The universe is not bringing things together. It is pulling them apart. It is not building toward connection. It is building toward isolation. It is not moving toward a state in which all the lonely observers find each other. It is moving toward a state in which the observers are gone, and the loneliness is complete, and there is nothing left to be lonely. This is the universe, not the universe of the comfortable illusion, the universe that looks full and alive and generous with its light when you stand under the night sky and tilt your head back and let the stars press down on your eyes, but the actual universe, the universe of the cosmic voids and the dark matter and the dark energy, and the accelerating expansion and the declining star formation and the aging galaxies and the long cold future of stellar remnants and evaporating black holes and final silence. The universe that is mostly made of distance and darkness and invisible forces and future quiet. The universe that produced, in one small corner of its enormous indifferent expanse, something capable of understanding all of this, and then will dissolve it, and then will forget it, and then will continue cold and dark and empty and indifferent, for a duration so vast that the entire history of everything that ever lived and looked and wondered will be less than a whisper in the total silence.